All right, guys. So I'm just gonna do a functions question quickly. Then we're gonna move straight into. We're gonna continue with graphs, right? First question. We want to find g of x minus two. So as you can see, we have x minus two inside, right? So if you have x minus two inside, wherever you see x with g of x, you're gonna replace x with x minus two in brackets. So Danielle, let me know if you're there. Danielle? Okay, I'm not hearing you. But this is going to be equal to x minus 2 squared, right? Minus 5. So all I did was I just replaced whatever was inside the brackets with x. So x minus 2 squared means x minus 2 by x minus 2, right? Minus 5. Now, if you want to expand this, it's going to be x by x, right? X by minus 2, right? Then it's going to be minus 2 by x, right? And then minus 2 by minus 2. First things first, x by x is x squared. X by minus 2 is minus 2x. Minus 2 by x is minus 2x. And lastly, minus 2 by minus 2 is plus 4. So if you notice, we have minus 2x here and minus 2x over there. So minus 2x is minus 4x, right? And 4 minus 5 is minus 1. Are you all okay with this question? Let me know.
Yes,
Yeah? All right. Cool. Now I want to explain something, eh? Let me explain something. There are multiple ways you can go about this question, but there's an easier way. And let me show you there was easier way. Guys, what do you put into an inverse function, x or y? Remember, the inverse function takes what and gives you what?
take a x and give me a y. Oh wait, no, take a y and give me a x.
Right, that's what the inverse function does. So this 11 over here is really a what value? You're really putting a what value into the inverse?
A y.
A y, right? So look at this, eh? Look at this. I could say that, guys, remember, and f of x is equal to y, and you know that f of x is equal to y? Yeah? We know that, eh? We know
Yes.
that f of x is equal to y. And over here, f of x is equal to 4x minus 1. So we're going to say f of x is equal to 4x minus 1. And we know that the y value is 11. So I could say 11 is equal to 4x minus 1. And from here, I could solve for x. If I wanted to solve for x, what would I do? So if I wanted to solve for x, I would need the x term to be the only thing on this side, but it's not. Right now, you have 4x as the x term, and you have minus 1. So we're going to take the minus 1, and we're going to move it across. If you move across minus 1, that's going to turn to 11 plus 1, and that would be equal to 4x. So 11 plus 1 is 12. So 12 is equal to 4x. How would I find for x now? Can I hear anybody? But you would divide both sides by 4.
Yeah.
Right, so 12 over 4 is 3, so x is equal to 3. And if you do a transfer, you could always plug this into f of x, and what are you supposed to get for y?
11.
Yes. And let's see if it'll work out. So f of 3 will be equal to 4 by 3 minus 1, because f of x is 4x minus 1. So 4 by 3 is
12.
12 minus 1 is
11.
right. We get back y is 11. So cool. That was one way you could do it. So guys, anytime you see an inverse question and a number is on the inside, you could attack the question like this. So remember, you plug a y value into the inverse function, right, to get the x value. So this is really y is equal to 11. So the question is, what value for x would give you y is equal to 11? So we know that f of x is y. So what we could do is we could actually replace f of x for 11, right? And from there, just make x the subject. That's one way you could do it. The other way would be to find the inverse and then put in 11. Aaron, you there?
Yeah, sir.
Aaron, you ready to get like real serious and just mash up this maths?
Yeah,
Like,
sir.
okay, good. So here what? I'm gonna be moving with a little bit of speed here, right? Right? The people that are here, I presume are they already are they like locked in and like are they want to actually pass? Because like we're gonna go, right? So it's gonna be more maths than anything. Right? We're gonna be serious. So Aaron, I'm gonna say f of x is equal to 4x minus 1. What's the first step?
Um, you have to say 4x minus 1 is equal to y, sir.
Right? What next?
You have to swap the x and the y.
What next?
Make y the subject by first moving the -1 on the right side, making it positive, and then dividing both sides by 4.
So y is equal to
To x plus 1 over 4.
right. All right, nice. So we have y now. So y is the same thing as f inverse x. So this is the option. This is the other option, right? Now, when you find the inverse function, now you just have to put 11 into it. So the now, I think you can see that it's f inverse of 11. So once you find the inverse function, you just need to put 11 into that. So you'll say f inverse 11, and that will be equal to 11 plus 1 all over 4. Right? And 11 plus 1 is 12, and 12 over 4 is 3.
3.
So all these are different methods you could take to figure out what f inverse of 11 would be. Right? So method 1, you know that 11 is y, so you could say 11 is equal to 4x minus 1. From there, you just find for x. That's it. Method 2, you find the inverse function, then just put 11 into that. Aaron, which one would you employ in the exam?
I would go for the first option, so do the inverse, but replace x with 11.
Yeah, this is a smarter approach. Because if you notice, they are not directly asking you for the inverse function. They're not asking you for the inverse function
Question.
directly. Yeah, Fit?
Does it only work for the inverse function, the first method? Oh,
Like,
okay.
wait, F it? Let me try
No,
to,
I saw you drew or inside the so I realized that means and or.
oh, okay, yeah, yeah. This is one method, right? Just put f of x is 11 and find for x. Or you could find the inverse, right? And then plug in 11. Both is fine. Nice. This was the hack I wanted to
The
show.
first one seem easier.
It does. But you realize if they're asking for f inverse, if they're just asking for f inverse x, you'd have to do this, right? If they ask you for f inverse x, you'll have to do this. But if they ask you for f inverse of a value, that means they're giving you a y value, and so you can solve for x. Right? Okay. So Aaron, now they're asking us for h of 1. So that means h of 1. So you actually plug in h of 1 into h of x. So tell me, Aaron, is it possible for me to find what h of 1 is?
Yeah, sir.
Right? H of 1 would just be equal to 3 to what power?
3 to the power of 1, sir.
Which is
3.
right. So now our problem becomes h. Remember, it was h of 1. So this now becomes h of
h to
what?
the power h Of 3, sir.
Exactly, h at 3. So my final answer is just going to be h at 3 is equal to 3 to what power?
3 to the power of 3, sir.
Which is
27.
nice. Nice. That's your answer. Right then now, some of that confuse you like real bad.
Yes, sir.
So then now you understand that we're finding. So if we
Yes,
find
sir.
h of 1 first, right? H of 1, right? Wherever you saw x, you just replace with a 1, got 3, right? 3. So this ended up being h at 3, h of 3. And from here, right, anywhere you saw x, you just replace it with 3. So 3 to the power 3, and we got 27. All right.
Yes, sir.
So guys, onto graphs. So I told you guys that when you're plotting points on a Cartesian plane, a point is made up of an x value and a y value. You're putting x into the function and you get the output y, right? And they also call this an ordered pair. So let's jump straight into our past paper question one time. So guys, what's the function in this question? The
F
function,
of x is equal to x squared, negative x, and negative 2.
right? So I need you all to understand that f of x is the same thing as what? F of x is the same thing as what? Do you all know? See if you can finish my sentence. So we have x here, and what do you think f of x would be called? Try the axis. The axis will give you a hint.
Fx?
They're calling this axis x, and what are they calling this one?
Y-axis,
Right, so what do you think f of x is equivalent to?
the x-axis.
Now, y.
Oh.
That is why, okay, you ever wonder why we just say let f of x be y? Because f of x is the output.
Or because it implants x onto y.
Yeah. So f of x is y. So some students might have finished the table, but they mightn't know what points to plot, right? So guys, get it in the head, right? Guys, please note that f of x is equal to y, right? And a point is made up of a what and a what value? A point. A point
X
is
and a Y.
right. So when you're working this question out, you're getting the x value, right? Minus 2, minus 1, etc. And you're plugging that into the function to find the, you're going to plug minus 2 into the function to find for the what value?
Y value.
Right, because remember, guys, I said you put x into the function to get the y value. Right, so if you have a Casio, your Casio could do this for you. Your Casio could do all the work in for you. Would you like to see how you can do it on a Casio or something or whatever? You have?
Sure.
Okay, what we're gonna do, right? On a Casio, you're gonna press menu, right? And you're scrolling down, right? And you're looking for table. Right? So the Casio, you press menu, then table. Then press equal to access table. It's gonna ask you to put in the function. Let me know if you're with me.
Yes, I figure I got it.
Right? To get x on the Casio, you're gonna press alpha, close bracket. That should x should pop up. Then you're gonna press x squared to get it squared. Right? Then minus to get the x again, press alpha, close bracket. Then to get minus 2, you just press minus 2. That's it. Let me know if you're with me. Faith, use your calculator should be able to do this.
Yeah, on mine it's more instead of thing, but I'm not getting to put the x.
To get the x, you need to press alpha, close bracket.
What's in the x?
To get the x, you need to press
The fx. Oh,
alpha, close bracket. You got true?
those brackets.
Yeah, alpha, close bracket.
No,
It's
delete.
it's
I
supposed
can press x squared.
wait, you get in the x in the calculator, or not?
No.
That's
Nah.
you need to press alpha first, then the close bracket button. So Faith, look at what I'm gonna do, right? I'm going to press alpha first, then close bracket, and I got the X. It should work for your calculator because I'm seeing the alpha is in red, and above the close bracket, it have a red
Got
X.
it. I got it.
Okay, good. Then you're gonna press the X squared button to get X squared, right? Then you're gonna press the minus, then alpha, close bracket,
Yeah.
right? -2. Guys, the next step, you're gonna press equal. Now, depending on how advanced your Casio is, it may ask you for another function. Just ignore this. If you want to find another function, sure, but ignore this
It
for now.
says start,
Wait, so for start,
right? And it says 1. It says
okay,
start with a question mark.
all right. So here what we're gonna do, right? Let's look at the domain here. The smallest value is what? What's the smallest value here? Any table,
-2.
right? So we want to start at -2. So press -2 and press equal. Right?
Okay, I got 5.
And should come up now,
Yeah.
right?
Yeah, I see an end with a question mark.
Right. We want to end off at what value? Look at our table.
3.
Right. Press 3 equal.
So press 3.
Yeah. And the next thing should be step.
And
Now,
again, step 1.
right. So step will tell the
Yeah.
calculator how much increments to go up by. So if you put a step of 1, it's gonna go like -2, then -1, then 0, then 1. It's just gonna keep adding by 1, right? And our graph has an increment of 1, so it's
So we
fine.
need to add any numbers on the screen.
Yeah, so like here it is, right? If you're starting from -2, right? You got add 1,
Yeah.
-2. So from -2, you go to -1. That'll be the next value your calculator will use. Then it will add 1 to -1 to get 0. And then the calculator would add 0, add 1 to 0, you'll get 1. The calculator will then add 1 to 1 to get 2. So it's going to increment by 1. It's going to keep increasing the values by 1. So we're going to start at -2, and they're going to increase by 1 till it reaches 3. Like what you're seeing over here. Like what you're seeing
I
over
think I
here.
have to start over.
And when you press equal, you should get the table.
Yeah, I got a table, so
So the table will tell you all the answers. So, Faith, because I'm gonna know what's going on, right? I'm gonna figure the final table. But
Start, end, step 2.
what's your step? Keep your step at 1.
I don't know. I think I did something wrong.
So,
I have to start over.
like it looks so real. Yeah, tell me what's going on. Right, so yeah, so Aaron, the answer for x is equal to -2 is
X, let me double check. 4, sir.
4, right? When is 0, when x is 0, it should be
-2, sir.
yeah. Casio saves lives.
I keep getting an error.
Right. Pete, take a video where you're plugging in. I sent it to me. I need to see exactly where you're plugging in to help you further.
All right.
Right?
Going on table.
But the long way to do the question would just be to put in whatever x is into the function. So now you have a sharp, right?
Yes, sir.
I said now, what are you going to do, right? If you want to get the y value here, You see how x is minus 2? That means you have to plug minus 2 into the function. So anyway you see x, you're going to write
-2, sir.
right. So you write minus 2. So remember, it's x squared. So instead of x, you're going to write minus 2. So minus 2 squared. Right? Instead of writing minus x, it'll be minus open bracket minus 2. Right? Minus 2. So look, all I did, I replaced x with minus 2. I mean, if you see in that.
Yes, sir.
So then now,
You can see the screen again. The last number.
the last number is 1. The step is 1.
1.
Or the last number you're talking about, like this, like anything.
Yeah. So
Or
it's 3.
yeah.
When it asks for step, what doing again?
Just put step as 1. Press 1 and then press equal.
1. Right, I got it.
Okay, nice.
But I see it -2 to the bottom of the screen.
All right, so you see what I see it?
Yes.
All right, so as you can see, when x is minus 2, f of x is
4.
right. When x is minus 1, you see calculator tells you is 0, right? When x
Yeah.
is 0, it tells you that f of x is minus 2. So yeah, now you know how to save time in the exam.
So just to be clear, f of x is y, right?
Yeah, f of x is y. F of x represents the
All
output
right.
function, which is y.
Okay, this is cool.
Right. So guys, here what, right? We have a bunch of points. Then now make sure you get in 4. Make sure you get in 4 to now. When you plug the whole thing into the
So I
function.
tried and I get 4.
Yes,
Oh.
sir.
Good. Right? And if you wanted to find f of 0, right? F of 0, wherever you see x, you would just put 0. So 0 squared minus 0 minus 2. As you can see, this whole thing here going to be 0, so we'll just be left with minus 2. Right? So our points will be what? Remember, a point is made up of an x and a y value. So what's the point here?
-2, 4.
What's the other point?
-1, 0.
Another point?
0, -2.
Another point?
1, -2. 2, -0. And
One zero.
3. Yeah, 2 normal 0 and 3 and 4.
Right, so guys, what is the smallest value on the x-axis? What's the smallest value for
0.
-2, sir.
-2.
right? And the biggest value for x is?
3.
Right, so we need to come up with an appropriate scheme. So -1, okay, so if I were to say that this was -1, yeah, that would make sense. -1, -2, right? This would be 0. And I need to go to 3. Let's see if that will work. So 1, 2, 3. Did my scale work? Let me know if it fits everything. Did it go from -2 to 3 on the x-axis? Did it work?
Yes, sir.
I think it works, yeah.
So I'm saying every 2 big blocks is 1 block, one space. So watch. And I don't want to make my graph too small. Like guys. If you said this was 1, this is 2, this is 3, the graph is gonna be very, very squeezed. Right? You want to take up most of the space. Right? On the y-axis, what is the biggest value?
4, sir.
Right? So let's see if the same scale works. So every 2 blocks is 1 unit. So 1, 2, 3. Does it look like it's going to work? Yeah, it does.
Yeah.
Right? -1, -2. So when you are plotting points, you start on the x-axis, then you go either up or down. So you go left or right first, then up or down. Let me explain. So my first point is -2, 4. right? Minus 2 comma 4. So my x value is minus 2 and my y value is 4. So here what we're to do, I want you to take a pencil and go by minus 2. And then then it says 4 on the y-axis. So I want you to go by 4 on the y-axis. That will tell you where your point is. If you want a better explanation, more conceptual, let me ask you a question. If we're talking about the x-axis, right? How do you think it could move? If you're on the x-axis, how do you think it could move?
Left or right, sir?
Across.
Left or right, right? If you're on the y-axis, how could you move?
Up or down?
Right, this will be a precursor to vectors, right? You need to know this when you're doing vectors anyway, when you're doing position vectors. So guys, we always start at the origin, right? Yeah, and then you always do the horizontal movement first. If it's minus 2, you think I'll move 2 spaces to the
To the
To
left,
the left.
sir.
right? And then I'm seeing positive 4
So you
on the
have to go up,
y-axis.
sir.
Exactly. And that would take me to this point over here. Do we understand how to plot a point?
Yes, sir.
Right? So this is going to be minus 2, 4. So that's my first point. My other point is minus 1, comma 0. So I'm going to start at the origin again, and I'm going to move how? How am I going to move?
Down.
Now, remember
What's
the
that?
value is the x value. So horizontal.
Left, sir.
And how much spaces am I going to move up or down?
One
Zero.
space, sir.
Now watch. What's the y
It will
value?
be 0. You're not
Um,
moving.
no spaces, because 0 is in the middle.
So I'm just going to stay over here. All right, let me explain that again. So I'm starting off at the origin. I'm seeing the x value is minus 1. So I'm going to move 1 space to the left, and then I'm going to stay there because the y value is 0, which tells me I'm not going to move up or down. I'm just going to stay there. Right? So Aaron, you okay with this?
Yes, sir.
All right. Next thing, Aaron. The next point is 0, comma minus 2. Again, I'm going to start at the origin. What is my x value?
0, sir.
So guys, if my x value is 0, am I going to move left or right?
No, you're gonna stay in the middle, sir.
All right, I'm going to stay in the middle. And where's my y value though?
-2, sir.
I'm going to move 2 spaces up or down.
Down.
Right, so I'm going to end up over here. All right, next onto the other point, 1, comma minus 2. So again, I'm going to start at the origin, and my x value is 1. So I'm going to move 1 space to my
Right.
right, and then from there, I'm going to move.
Two spaces down, sir.
Right, so I'm going to end up over here. Yes or no?
Yes, sir.
Right, my next point is 2, 0, 2, 0, 2, comma 0. So I'm going to start at the origin. I'm going to move 2 spaces to the,
Right, sir.
and my y value is 0. So am I going to move up or down?
No, you're staying in the middle, sir.
Right. Stay over there. And my last one is 3, comma 4. 3, comma 4. And guys, this is 6 marks. This is 6 marks. 6 marks. A very easy 6 marks there, I see. What do you think? Oh, you think this is an easy 6 mark?
Yeah, looking easy,
Yes,
sir.
sir.
Yeah, you don't want to lose this easy 6 marks. You really don't. Right?
This is a paper 3 or paper 2?
Some people too. Right? 3, comma 4. So I'll move 3 spaces to my right and then
Right.
4 up.
4 spaces up.
Yeah. So guys, this shape looks like a what? A line or a quadratic curve? This shape, does it look like a quadratic curve or a line?
A curve.
A curve.
Yeah, this is a
Good.
quadratic curve. All right, so let me just draw this thing. Oof, wouldn't look perfect. They don't expect it to try perfect in the exam, eh? Like they don't. They don't expect like perfection. Expect that it would catch them. They expect But let me know if you understand how I came up with the sketch.
Yes, I get it.
Awesome. And here I would advise you, right? Anytime you do a graph, right? Just label the graph, right? So we're gonna say, so now right next to the graph, I'm going to write f of x is equal to x squared minus x minus 2. And this isn't like physics, you don't have to put a scale. If you realize they already give you the scale, right? So you don't have to put a scale and thing. It's not like physics. So that's that, 6 marks. Do you all think you get a 6 marks in the exam?
Yes, sir.
How about the rest of you guys? Or you think I'll if you get a 6 marks?
Yeah.
Okay, I think so. I think this is an easy 6 marks. So remind me, guys, right? If you want to get coordinates and you are given a function, you have a function, right? And you want to get coordinates. How are you going to do that? Let me just say I give you a function, 5x. And I tell you x is equal to 1. How am I going to find a set of coordinates?
Yeah, fine for
Yeah, say
y.
5. You gotta replace the x with 1, so and say 5 by 1.
Okay, so do you all understand that this coordinate will be 1, comma 5 or not?
Yes,
Do you all understand that?
Yeah.
Okay, so again, if you have a function and they want to get a y value, you're going to take your x value and you're going to plug it in. That will tell you the corresponding y value, and that will be a point on the graph. All right, guys, are we okay with this? Let me know.
yes, sir.
Yes.
All right, good. Okay, right. So we're okay with plotting points on the Cartesian plane. Nice. Right? Something that I want to go through, right? You need to be able to figure out the axis of symmetry, the roots. You need to figure these things out. So guys, do you all know what the roots are for a curve? The roots.
No.
No, sir.
All right, so the roots, these are the points. These are the points where the curve cuts the x-axis. So guys, what values of x did the curve cut the x-axis at? Let me hear you guys. What is it?
-1 and 2.
Yeah. So my roots would be x is equal to minus 1
-1.
and x will be equal to 2. And there are two ways you could figure out the roots, right? If you're given a question and they ask you to find the roots of a quadratic, there are two ways you could do it. You could use the quadratic formula or you could factorize, right? If you want to factorize, let me show you how you would do that. So we have x squared minus x minus 2, right? So we have x squared. So these are methods in which you could find the roots. Finding the roots. So this is method 1. You could factorize and put that equal to 0. Why am I putting that equal to 0? The reason I'm putting it equal to 0 is because if you add, guys, tell me, right? Tell me. If you add the x-axis, what is your y value? If you're on the x-axis, what do you think your y value is?
0.
0.
Yeah, exactly. Right? And if we know y is equal to 0, right, we could put the entire thing equal to 0 because we know that f of x is y, right? Everything making sense. So when you want to find your roots, you could factorize. So our quadratic was x squared minus x minus 2. So we're going to put that equal to 0 and we could factorize this. So you all remember how to factorize that quadratic?
Yes, sir.
Right, so to get x squared is x by x. Then we're going to look at the last number. What is the last number here?
2, sir.
Minus 2, right?
-2, sorry.
So how can I multiply to get minus 2, but add to get minus 1 in the middle?
1 by -2, sir.
Correct, because if you add 1 and minus 2, right, you're going to get minus 1. And if you multiply 1 and minus 2, you're going to get minus 2. Right, so plus 1 minus 2. Now, guys, anything by 0 is what? Anything by 0 is?
Itself. I'm 0, sir, 0.
So let me blow all in mind, right? What value for x would make this bracket 0? When x is what?
0.
No. If x is 0, 0 plus 1 is 1. That doesn't make this bracket 0.
-1.
Yeah. What's negative 1 plus 1?
0.
0.
0 by anything is
0.
0. So that would be a solution, right? So I would say it would say x plus 1 is equal to 0, and it would solve for x. So x is equal to -1. Because when x is -1, this bracket gonna turn to
0.
yeah, and we don't even care with having this bracket. 0 by anything will give us back the 0. So we solved the equation there. And guys, if you look in this bracket, what value for x would make this bracket 0? What minus 2 is 0?
2.
2.
Yeah, some other value is 2, right? So you would say x minus 2 is equal to 0, and you would move across the minus 2 and you get 2. So that's how you would find the roots using the factorization method in case they bring it in the exam. As you can see, didn't that line up with the graph? Let me know, guys. And you guys see?
Yeah.
Yeah. And the other way is the quadratic formula. Right? Do you all know the quadratic formula?
No, sir.
I'm not sure.
Right. So x would be equal to negative. I realize as of recent times, they are making you use the quadratic formula. So I say I'm supposed to show all of this. So x would be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? And I believe this is in the formula sheet. If you forget, yeah, it is. Watch. It is. Guys, look at this. They even give any trigonometric ratios and thing. They give, so they don't have an excuse, man. They giving you sine theta is opposite over hypotenuse. They're telling you cos is adjacent over hypotenuse. Babe, or they could mash up this exam, man. Yes, guys. They even given you the sine and cosine rule. Watch that. Aaron, and you think you could, Aaron, and you think you could get one or a two? God forbid you get two, but like, and you feel like you could get two or one?
Yeah, sir.
I think so, right? I think so. So to use the quadratic formula, you need to figure out what A, B, and C is for the quadratic. Now we're gonna look at that earlier, like earlier when we were doing algebra, right? You're not seeing it, right? But if I were to ask you how much x squares is that, how much you would tell me, Aaron? That's how much x squares is that? Like
1x squared.
right, you're not seeing it, but that's understood to be 1x squared. This is understood to be 1x, right? So A, B, and C are just simply the coefficients, right? For the terms. So what do you think A would be equal to?
1.
What do you think B would be equal to?
1.
Now, be careful with the signs.
Oh, -1, -1.
And C would be equal to?
-2.
So we're gonna plug this into here, right? Right, so x would be equal to negative b, so that'll be negative open bracket -1, right? Because b is -1, plus or minus the square root right, of b squared. Now b is minus 1. So minus 1 squared minus 4. A is 1, right? And c is minus 2. And a is 1. So 2 by 1. So guys, the hardest part of the quadratic formula is just to figure out what a, b, and c is, which is not hard. I think you all can figure that out. What is negative by negative 1? Tell me, Aaron, move what speed? What is negative by negative 1?
Negative by negative 1, sir. Positive 1.
Right? Minus 1 squared.
Positive 1, sir.
We have 4 by 1 is 4, so minus 4 multiplied by minus 2. What's minus 4 by minus 2,
Positive 8, sir.
right? And 2 by 1 is 2. If you simplify this, you'll get x is equal to 1 plus or minus the square root of 9 all over 2. So you have two solutions here, a positive solution and a negative solution. So the positive solution would be x is equal to 1, right? You see that plus or minus? That you see that plus or minus there? Because
Yeah.
anytime you find the square root of something, right? Take, for instance, to get back 9. And you can say 3 by 3 to get back 9, as well as minus 3 by minus 3.
Yeah.
Yeah, so that's why I see in plus or minus over there. So the positive solution will be 1 plus 3 all over 2. 1 plus 3 is 4. 4 over 2 is 2.
It's 2.
That's one solution. Then now, let's look at the negative solution then now. So then now, any square root of 9 is 3.
Yes, sir.
Right, so the negative solution would be when x is equal to 1 instead of plus minus. Minus 3 all over 2. Tell me then now, what is 1 minus 3?
Yes, sir.
Positive or negative 2?
Negative 2.
Right, what's negative 2 over 2?
1, sir. Negative.
Negative
1.
1. Yeah. Then now, as you can see, this is the same answer we got. What?
Yes, sir. Yeah.
So you need to know this for the exam. You need to be able to find the roots of a curve, quadratic curve, right?
Yes, sir.
Okay, word. So here what? I want to start coordinate geometry, right? Let's start coordinate geometry. When you look at graphs. In coordinate geometry, you get fed up looking at graphs. All right. All right, so guys, first things first, what's the equation of a line? Does anybody know the
Y
equation?
equals mx plus c.
Y equals mx plus c.
Right, y is equal to mx plus c. Great. M stands for the,
Gradient.
right, M stands for the gradient. What's the formula for the gradient?
Y, I think is
Y2 minus
x1.
Y1 over
Yeah, y2.
X2 minus X1.
Right. I remember it as a change in y, right? Change just means the difference between 2 points. So y2 minus y1 all over x2 minus x1. Now, guys, if you want to find the gradient, you need 2 points on your line. Some students, I noticed they would take points anywhere. No, it must be on the line. So 2 points on the line. So another word for gradient, by the way, is slope. Sometimes you might see they're asking you for the slope. Right? As you see, that means the same thing as gradient. Don't get confused if you see the word slope. Right. Just some things, just some general knowledge. If you see a gradient in this direction, that gradient means, you all know, positive or negative.
Negative.
Right, this is a negative gradient. If it's completely flat, that's a gradient of
Positive.
now. And by the way, another word for slope is steepness. So if I ask you how steep a flat road is, would you say it's steep? Would you say a flat road is steep?
No, sir.
No.
No. So you would say this has a gradient of 0 because it's not steep. So 0, right? So over here, I would say m is equal to a negative. So m is negative. Over here, I would say m is equal to 0, right? And over here, it looks like the steepness is what? Increasing or decreasing? Let me explain, right? Imagine you're driving in a car.
It's increasing.
Yeah, because then you're gonna keep moving on more uphill.
Yeah,
Yeah, over here, imagine if you're driving a car, right? The steepness
it
decreases.
decreases.
Right. So we can make sense of these things. So these are some general things to keep in mind. Right, so m is a gradient, slope steepness. The formula for it is y2 minus y1 over x2 minus x1. Please keep this in mind. Right, next thing, do you know what C stands for?
The midpoint.
Nah, not the midpoint. C stands for the y-intercept. And the y-intercept is where the line will be cutting the y-axis. Right? Right, so this is the point where the line will be cutting right. So if you want to find the equation of a line, and by the way, this is the equation of a line, eh? If you want to find the equation of a line, right, you need two things. Well, number one, you need the gradient. Number two, you need the y-intercept, right? And to find the y-intercept, you would typically need a point on the line, right? A point on the line. So this is going to tie us directly into linear programming. So guys, just please take a screenshot of this for me. Take a screenshot.
I have it.
All right. Do you all have it?
Yeah, so
Okay. So guys, let's just run through the basic type of graphs, right? Because like I said, this is directly going to tie into linear programming. How much of you all have trouble with linear programming?
I don't know if we ever did linear programming in school.
You'd be at a serious disadvantage if you never did that, because I was coming paper 3, and it's like, what, 10 marks sometimes?
Well, so I not doing paper 3.
Oh, you're not doing paper 3?
I doing paper 2.
Oh, okay, so you're not too worried about, okay. All right. How much are you doing paper 3 by show of hands? Tell me.
Me.
I had to do it too.
Okay, noted. Also try to keep that for everybody, right? But yeah, it's just similar linear programming. Let's just go through the basic type of lines, right? So diagonal lines, if especially if it's a diagonal line, if it's a diagonal line, that means it has a gradient, right? And it will definitely be in the form y is equal to mx plus c, right? If it's a horizontal line, and please remember this, right? Because when we started doing linear programming, you need to know this, right? If it's a horizontal line, right, it's going to be in the form y is equal to k, where k is some number. If it's a vertical line, it's going to be in the form x is equal to k, where k is some number. You'll see what I mean shortly. So guys, I just draw a line passing through what?
The
Y.
y-axis.
Wait till I make a ruler. And that line passed through what?
The
The
y-axis.
y-axis.
So I think I would say y is equal to, the equation for this line will be y is equal to, make a guess.
Um,
What did it pass through?
1.
So y is equal to 1. Does that make sense? Because it passed through 1 on the what axis?
The y-axis.
Everybody in class, does that make sense? You all understand
Yes,
what I'm
sir.
saying? Okay.
Yeah.
Okay, if I draw a line here, I would say that this line is
Y is equal to 8.
right. Do you all understand why I said if it's a horizontal line, it'll be uniform y is equal to k, where k could be any number.
Yes, sir.
Okay, cool. So I have a question then. What do you all think this line will be called?
X or YX.
Y and x.
No, no, no. I want to let it continue the pattern, right? So guys, let me continue, right? So like, okay, if I draw this line, right, what would you say the line is? Y is equal
Y.
to,
Y.
Y is equal to 2.
okay, so if I take this line, right? Wait, okay, so guys, if I draw that, if I draw the line there, that's y is equal to 1, right? So if I keep going down and I add 0,
Y is equal
Y is
to
equal to
0.
0.
right? And let's tie that into what we just now realized. You guys just told me that the y value here is
0.
exactly everything making sense, right? So if you are on the x-axis, the y value is
0.
exactly, and you can see what I'm talking about, right? Because this line over here, what's the equation for that line?
Y is equal to 0.
Exactly, right? I hope these things making sense finally. Like, like you're clicking on, it's like, wow. All right, what would the equation on this line be? Wait, tell Mr. Robert.
Y is equal to -5.
Great. Okay, so we understand that if it's a horizontal line, it'll be uniform y is equal to k, right? Okay. If I had say this line over here, that'll be what?
X is equal to 1.
All right. What do you think about this? That'll be x is equal to
X is equal to 0.
perfect. I thought I would have tricked you, but no, I'll be better than that. What do you think I would call this?
X is equal to -8.
Awesome. And any line. So guys, I showed you what horizontal and vertical lines would look like, right? Diagonal lines would be in the form y is equal to mx plus c. You have to find the y-intercept and the gradient. But for horizontal and vertical lines, it's easy. You're okay with this so far, right? Let me know, guys.
Yes,
Yes,
sir.
sir.
Right, so here we're going to jump straight to past paper questions and apply the knowledge we know so far. Right, just some things to keep in mind before we move forward. Right, guys, when you hit it with parallel, right, those are lines that go in the same direction but never one.
Never touch.
Never touch.
Right, so let me explain something. The gradient of parallel lines are the same, right? Are the same. So I'll give you an example, right? I would just say we had this line here, right? And I had this line here. Guys, can we see that those lines are parallel to each other?
Yes, sir.
Yes, sir.
So these lines would have the same gradient. So the gradient for this would be, the gradient is 4. The gradient for this one will be
4.
4.
okay, great. Now next thing you need to know. The gradients of perpendicular lines are the negative reciprocal of each other. Wow, crazy big word, right? How much are they getting scared because I say that? The gradient of perpendicular lines are the negative reciprocal of each other.
So is the opposite?
Not quite. A little more than that. If you say opposite, yeah, but I need to understand to what degree you say that. So let me get an example, right? So let me use the same one. M is equal to 4. Guys, do we know what perpendicular means by chance? When he was doing circle theorem, you'd see that perpendicular means what angle to?
Hmm.
What angle we talking about? Let me get a hint. Remind me, guys.
90 degrees, sir?
Yeah. But let me just pick up one prior knowledge. Guys, this green outer line, what's the name of that?
The tangent.
Tangent. This point in the middle is called the
In center.
this line going from the center to the circumference is called
Radius.
Radius.
the angle between the radius and the tangent is
90 degrees.
say we say it's perpendicular, right? So perpendicular means 90 degrees too. Right? 90 degrees too. So guys, if I draw these two lines here, do they look like they're 90 degrees apart or not?
No.
What about this? Do those lines look like they're perpendicular to each other, 90 degrees apart?
Yeah.
What do you all think?
Yeah.
I say yeah, right? And we could see why. Now here it is, eh? What does negative reciprocal mean? Well, it means a crack. I'm joking, like it. Not bad, right? It's not bad. It's looking hard, right? But it's not easy. You're just gonna change the sign and flip it. Right? All right, it's in English. So negative reciprocal just means you're gonna change the sign. So change sign, flip. So let me show you what I mean by that, right? So guys, and we could all agree that 4 is the same thing as 4 over 1. Yes or no?
Yeah.
Okay, so if I change the sign for that, if I change our sign, so 4 over 1, if I change the sign, I go into the negative, yeah? Right? And then I'm going to flip it. If I flip 1 over, my brain is also correct and tell people the answer. If I flip 4 over 1, what will that be?
A
A
quarter.
quarter.
Right, so negative a quarter is the gradient of the other one. Are you understand what I mean? So change the sign and flip. Let me know. Let me know, guys.
Yeah. Get.
Are you understand it?
Yes, sir.
Okay, good. Let me just give another example because I have trust issues. Let me just say the gradient of this line, right? Um, gradient of this line M1 is equal to negative 2. What do you think the gradient of the other line would be then?
A half.
Excellent. Excellent. Yeah, would be a half. Right? Would be a half. And if you are confused, watch this, right? Watch this. And negative 2 is the same thing as negative 2 over 1. Yeah?
Yeah.
Right. So first things first is negative, right? So forget about the negative, change the sign. We're going into a plus. Then we're going to flip it. 1 over 2, positive a half. Easy or hard?
Easy.
Okay, nice. Nice. Let's move on to some other things that you need to know. Generally speaking, when you're doing coordinate geometry, right? You need to be able to find the perpendicular bisector, right? Perpendicular bisector. Okay, so guys, we know that perpendicular means what? What angle?
90 degrees.
90 degrees.
And bisect means to cut in. Make a guess.
Cut in half.
Huh?
Right, cuts in half. So add them together, right? Perpendicular bisector. Watch. Imagine you had a line A to B. Imagine you have this line, right? Call this A, call this B, right? The perpendicular bisector, right, would be a perpendicular line passing through the midpoint of this. So this is what the perpendicular bisector would look like. If you're extremely confused, Salma, or is it self-explanatory? Do you think it's self-explanatory?
Yeah.
Because it's perpendicular, so 90 degrees too, and it cuts in a line in half. So that's why we say perpendicular bisector, right? Now, guys, when dealing with the perpendicular bisector, you need to figure out, right, what the middle point is. So if you want to find the midpoint, the formula for the midpoint that you need to know is, and this formula really isn't really no rocket science, yeah? Like this real easy. And if you want to find the middle, you just add two things and divide by two. Yeah?
Yeah.
So watch this, right? The midpoint is just x1 plus x2 all over 2, comma, y1 plus y2 over 2. Even if you forget this in the exam, you feel like you could guess it and figure it out.
Yeah.
I think so, right? I think so, right? And so I'm gonna just tie everything in shortly. Yeah. So question, guys. Let's just say that this point here was x1. Let me just call this the first point. First point. And let me just call this the second point. If this is the first point, I would say that this is x1, comma y1. And if this is the second point, I would call that point what? Take a guess.
X2, comma Y2.
Right? X2, comma y2. And well, we know how you'd find the midpoint, right? You'll find the midpoint using this formula. Yes or no?
Yeah.
Right. Another question. Let's just say, we know the gradient here looking like 0, right? But let's just say hypothetically, let's just say the gradient here was 2. If the green line is perpendicular to the blue line, what do you think this gradient is supposed to be equal to? Since they're perpendicular, use what you just learned and apply it over here.
A half
Not just a half.
minus a half.
Yeah. So here what I'm saying, right? To find the equation of a line, you need a gradient, right? And you need a point on the line. That's the main things you need, right? So guys, if I ask you to find the perpendicular bisector of a line, this is how you would go about it. The first thing you need to do is figure out what point the line passing through. How would I do that? If I give you 2 points here, how would you find the center point or the middle point? Using the what formula?
E midpoint.
Exactly.
X1 plus X.
Yeah, you'd use the midpoint formula. And if I told you what this gradient was, would it be hard to figure out the gradient of the perpendicular line?
No.
No. And from there, you could use y is equal mx plus c to find for c and complete the equation on the line. Right? Awesome. Right? The one thing you had to know again, you have to know two things, right? So the other thing you need to know what the length of a line is. Length of a line. the length of a line is just, right? So length of a line is just equal to the square root of x2 minus x1 squared, which this just comes from Pythagoras theorem, by the way. Y2 minus y1 squared. Yeah, guys. You guys okay with that so far?
Yes, sir.
So we're moving with speed, eh? We're moving with speed. Trying to move a little faster. Because if I could, I want to finish linear programming and do some matrices, no vectors tonight. Vectors real easy. I feel like, okay, vectors will make you use your brain, but the thing about vectors is not really much maths. It's more like you're trying to figure out directions. Who here,
What?
who here don't know about directions? Anybody get lost real easily?
Me?
Oh, they might have some problems with vectors because when you're doing vectors, you need to like look at the diagram and see how you go from one point to the other point and thing. And how would you travel from one point to the other point? All right. So guys, the next thing you need to know. The point of intersection between two graphs represents the solution to the system of equations. All right, just like that, we finished coordinate geometry. This is everything that you need to know, right? So, take a screenshot of this, right? You'll need to know how to find the perpendicular bisector. You'll need to know how to find the length of a line, and you'll need to know that the point of intersection between two graphs represents a solution for the system of equations. So, when you have a screenshot, let me know.
Yeah, I
Yes,
have
sir.
screenshots.
All right? Make sure you have a screenshot of this.
Yeah.
Yes, sir.
Okay, good. Make sure you have a screenshot of
Yeah, I
this.
got it too.
Okay, good. All right. So who wants to do the first coordinate geometry question, remember? We don't have much time to waste, so tell me one time. Otherwise, I just can't volunteer somebody.
I could try it.
I like that spirit. That's good. That's good. So lines L and M are drawn on the square grid below. Before we even start the question, it looks like those two lines are what to each other? Parallel or perpendicular?
Perpendicular.
Perpendicular.
Right. I mean, we will see, right? We will see. Write down the coordinates of the x-intercept of line L. If the y-intercept is where the graph cuts on the y-axis, what do you think the x-intercept is?
Wait, cutting the what?
Line cuts the x-axis.
Right. Intercept means to cut, right? So this is where the graph is cut on the x-axis, right? Cuts the x-axis. So where is the line cutting? Where is line L cutting the x-axis? So this is line L over here. Where is it cutting the x-axis? At what value? At what value for x?
6.
Right? Can we see that?
Yeah.
Right.
Yeah.
That's food. Right? 6. Right. Y-intercept. The y-intercept is where it cuts in the
Y-axis.
Y-axis.
right. And we're looking at line M here. Where is it cutting the y-axis?
3. Oh, wait, no. -2.
-2, yeah.
Yeah, -2, right? And just to clarify, yeah, they did what the y-intercept. So the y-intercept is -2. Okay, guys, those are easy 2 marks. Let me know.
Yeah, easy
Yes,
to
sir.
mark too.
Right. Things gonna get a little harder now, right? So somebody was doing it. Come on. Again, I probably know it. Like I know your name, but I can't see who talking. We just
Adhika.
all right, Adika. I know you, right? You're real good. I know you. It's just like, you know, I only know it for like a short period of time. Even though like we close. Like I would consider everybody here like, a little family, but like I know it for a little bit of time. So if I don't know your name, don't ignore her, right?
Yes, sir.
If I can't recognize your name from your voice. Yeah. So Adika, get this question I reached from like real fast. Real fast.
The equation of line L is x plus 2y minus 6 equals 0. Find the value of k given that the point 9k lies on line L.
Right. So I want to explain something, right, Adika? If a line, if a line, what's in? If a point, so if you have a point, right? So if a point lies on a line, it's supposed to satisfy the equation on the line. It is supposed to satisfy the equation. Okay, when I say satisfy the equation, does that confuse you? Be honest.
So, really,
Right. If you are confused, anytime I mention the word satisfy, right, I mean that the left-hand side is supposed to be equal to the
the right hand side?
right. That's what it means. So they give us an equation here. Is this uniform y is equal to mx plus c by chance?
No.
No, it cannot all over the place. But we don't need it to be uniform, right? Let me show you what we're gonna do. So they are saying that we have an equation of a line here, right? And they give us a point. And they said that the point lies on the
L.
right.
Line.
If a point lies on the line, what we know.
That is satisfying the equation of the line.
Exactly. So here what we're gonna do, right? They gave us a point 9, comma key. For any point, the first value is the what value? X or Y value.
The x value.
And the second point is the
Y.
so and the equation of the line they gave us was x plus 2y minus 6 is equal to 0, yeah?
Yeah.
So and it told us this point lies on the line. So you know what? In doing that, we can make an equation to solve for k. Because we know the left-hand side is supposed to be equal to the right-hand side. So you tell me, instead of writing x, what am I going to write instead?
9 plus 2y.
Right? 9 plus 2y. But what is y? What is y?
Y is k. Will be 2k
Right?
minus 6 equals to 0.
Right. What is 9 minus 6?
3.
3.
So will I confuse you if I write 2k plus 3 is equal to 0?
No.
I just simplify this one time, right? So 9 minus 6. And I get 3. So how would I find for k now?
You have to carry the 3 over on the other side too.
Adika. Let me ask Adika, right? But you're
Okay.
correct, right? So Adika, what is the unknown here?
Is 2.
Nah,
Well, k.
okay, so k, right? But what is the k term? What is the k term here?
2k.
Right, so 2k should be the only thing on that side. Is 2k the only thing on this side?
No.
No. So we have to move across the tree then. Understand?
Yeah, so it would be 0 minus 3.
Better yet, it would just be minus 3 because 0 represents nothing.
Yeah,
Guys, don't get confused. Like if I write 0 minus 3, that's the same thing as minus 3. So you could just write minus 3. 0 represents nothing, right? So you move across to minus 3 one time. Right, so Adika, what next?
um, divide
Yeah, I
on
want
both
to
sides.
divide both sides by?
2.
Yes. So k would be equal to minus 3 over 2, right? That would be equal to minus what?
1.5.
Exactly. Tell me. You understand that, right? Like, tell me if you understand that.
Yeah,
Right. So, guys, remind me, if they are telling you that a point lies on a line, then that point supposed to do what to the line? What's it supposed to do what to the equation? That point supposed to do what to the equation? It's on the screen, I promise. It's on
I
the screen. Starts with S.
Satisfy.
Yes, supposed to satisfy the equation. So what you're gonna do is you're gonna take that point, you're gonna plug it into the equation of the line, you're gonna make an equation, and you're gonna solve for your unknown. Is there anybody that didn't understand this at all? Faith, let me know if you didn't understand this at all.
I didn't understand that at all.
Okay, I'm happy that you're honest. That's good. So, Faith, I want you to read the question with me. Read back the question out loud.
The equation of line L is x positive 2y and negative 6 is equal to 0. Find the value of k given that the point 9k lies on line L.
Okay, so first thing, Faith, I want you to stay unmuted, right? If a point lies on a line, when you plug in those values, it's supposed to satisfy the equation. In other words, the left-hand side is supposed to be equal to the, tell me,
Right-hand side.
right. Now, I know you're a practical person. So let me show you the proof here, and you might be like, oh, so we got k to the minus 1.5, yeah? That's what we got.
Yeah.
Now, if that's correct, when we plug it into the equation, the left-hand side is supposed to be equal to the right-hand side. What's the right-hand side?
0.
Right, so we're supposed to get 1 on the left-hand side.
0.
Okay, let's see if that's the case, right? So we got 9, comma 1.5. What is x and what is y? Tell me, what is x and what is y? Maybe this is our point of confusion. For any point, right?
And y 5.
So you said that 9 was x and y was 1.5?
Yeah.
All right, so anyway I see x, what am I going to write instead?
9.
Anywhere I see y, what am I going to write instead?
1.5.
And if we are correct, it's supposed to be equal to the right-hand side, which is?
0.
Plug that into your calculator and I'm going to make it. All right, so Faith, you got I'm going to make it, right?
I think I did something wrong because I get 6.
Well, let's see. So let me try. So 9 plus 2, open bracket, 1.5, close bracket, minus 6 equals or something is wrong. That's really weird. Let me check back to working. That kind of sus. That's really sus.
Mhm.
Give me a moment. While I re-examine this to see if any
It's
mistakes.
it's negative 1.5, eh?
Oh,
Oh,
You
okay.
have
That's fine.
positive in
Oh,
the
okay, okay. Yeah, try that now. Try that. Yeah, it's supposed to be negative 1.5. Check that from okay.
yeah, I got the 0.
Right. So Faith, do you understand what I say now? Like when I say you have a point on a line, it is supposed to satisfy the equation.
Mm-hmm.
So here
But I
what?
don't understand how shell working.
Right. So let me
You
reverse it.
can run that back.
Right. So let me reverse engineer this, right? So starting off like this. This point supposed to do what to the equation? It's supposed to do what to the equation?
Um, be equal to it.
So it's supposed to satisfy the equation. So it would make the left-hand side equal to the right-hand side. First things first, what is x and what is y here?
The x is 9 and the y is k.
Right. So I'm gonna plug that into the equation now, right? Because it's supposed to satisfy the equation. So anywhere I
Mm-hmm.
see x, I'm gonna write what instead,
You're going to write 9.
right? So you understand how I said x is 9, right? And anywhere I see y, I'm gonna write
Okay,
what instead.
you're going to write k. All right.
So we got 9 plus 2k minus 6 is equal to 0. Is this an equation you could solve for?
Yes,
Yeah, you know how to do that, right? What's 9 minus 6?
3.
Right? So you end up with 2k plus 3 is equal to 0. And you know how to do this. Yeah, check that.
Yeah.
Define for k, you just move across the 3, right? And then you divide by 2.
All right.
You good?
Yeah, I have it now.
Okay, right. So Adika, let's continue, right? So they want us to figure out the equation of line M in the form y is equal to mx plus c. Now, Adika, here what I'm telling you, right? If you want to find the equation of a line, you need the gradient, right? You need the gradient, which is m, right? And you need a point on the line to find for c. Point on the line, right, to find for c. Or if you already have it in the graph, that makes things really simple for you. So, Adika, line M. We're going to look at line M, right? So,
Yeah.
this is line M. Do we already have the y-intercept?
Yes. -2.
So, we already have c, right? So, we don't have to do any fancy working. The only thing we're missing is the
The gradient.
right. So let me explain something. Adika, you could pick any single 2 points on this line, any two you want, any two. It doesn't matter which one you select. The point is, they must be on the
The y line.
no on the
On
M
the
line.
M.
Yeah, right. Students would go and take points all over the place. I'm not sure why, but don't be like that, guys. If you want to find the gradient of line M, you're strictly dealing with line M, nothing else. So Adika, I want you to read off a point from on this line.
Um, 2 and -1.
All right. So if you tell me 2 and -1, that would carry me over here. That point is not on the line.
Oh. Well, 2 and 2.
Right. That point is on the line. Right? Okay, come on, that point.
3 and 4.
Right? 3, 4. Yeah. Guys, is everybody okay with the points you picked?
Yes, sir.
Is it legal in the sense that it's online,
Yeah, it really got.
Oh,
I think like that the best points that you pick because you don't have to go and look all in them smaller grids and thing. Them 2 points is some good points you pick.
yeah, them is nice points, right? Some other nice points, some other nice points would be like, 0, comma minus 2, right?
Yeah.
1, comma 0. Everything else is ugly, right? Okay. So we have 2, comma 2 and 3, comma 4. 2, comma 2 and 3, comma 4. 2, comma 2, 3, comma 4. So guys, which one again doesn't matter. You could choose. It doesn't matter which one I call the first point and which one I call the second point. It really doesn't matter. If you do the maths correct, you'll get the correct answer. But you need to pick one at the end of the day. So, Adika, which one do you want to call the first point? Again, it does not
3
matter.
and 4.
And I call this the first point.
Yeah.
And if that's the first point, you call this the second point. So that would make these values x1 and
Y1.
right? X1 and Y1. And what do you think I'll call the other one?
X2, Y2.
Guys, do we understand everything so far?
Yes, sir.
All right. Remind me, guys, what's the formula for gradients?
Y2 minus Y1 over X2 minus X1.
Right. Right. Do we know what Y2 is?
2.
2.
Right, Y2 is 2. Where's Y1?
4.
What is X2?
2.
Minus X1. Where's X1?
3.
Right. Where's 2 minus 4?
-2.
Right, -2. And guys, would this be a legal move to make?
Yes, that will be legal.
It wouldn't.
That's very illegal, eh? Don't do any exam. No, no, no. Let me explain something, right? Yeah, before you can work this out, you need to actually simplify the numerator first and simplify the denominator. You can't do this because because you're taking away 4 from 2, right? It's currently being involved in a difference. Same thing in the denominator. You can't cancel off that. You need to actually work the numerator, right? And then work the denominator.
I mean, if you know
So-
as in the same thing, it's can say one thing.
No. Or like over here.
Yeah.
Yeah, but guys, don't do this, eh? If you was gonna do it, don't do it. You need to work the numerator.
Very good deal, boy.
Yeah, they're nearly going to jail. Right. So 2 minus 4 is minus 2. What is 2 minus 3?
-1.
-1.
Right. What's -2 divided by -1?
-1.
No.
Just 1.
No. Wait until guys, I have a calculator, eh? If you don't trust yourself, wait until the calculator and tell me the answer. -2 divided by -1.
2.
2. Yeah. Guys, watch this, right? Forget about the signs. Right? How much times 1 could go into 2?
Oh, okay, I now see it.
How much times 1 could go into 2?
2
2
times.
And a negative divided by a negative is a plus.
Positive.
It's a lot.
Positive.
I say just 2, right? Just 2. Now, guys, do you think I would have gotten a different answer if I switched the points?
No.
No, I get the same answer, right? Some of them might have some trust issues, so I'm gonna just show it quickly.
sir. And if you take any other points on that same line, so you'll get the same answer.
Same answer. Same answer. So long as it read it off correctly and you use the formula correctly. And you don't do any illegal maths. Right? Please don't do any illegal maths. Only Tavon could do that. And that's why he's failing his courses right now.
Oh, Lord.
Tavon, that's mine. Tavon, you need to move away from the illegal maths. Yeah. Right? So yeah. Again, the gradient formula is y2 minus y1, right, over x2 minus x1. Let's have what to plug in. What's
4 minus 2 over 3 minus 2.
What's 4 minus 2?
2 over 1. And the answer will be 2.
Guys, you see, it doesn't matter. Matter of fact, it'll be easier like this, right? But yeah, we good? We okay, guys? Let me know.
Yes, sir.
Yes, sir.
Right. So we successfully found the gradient, right? We successfully found the gradient. And what was the y-intercept from the graph? Where was m cut in the y-axis? At what? Where was m cut in the y-axis at?
Minus 2.
Right, watch. This is the y-axis, right, guys? And m was cut in it at minus 2. Can everybody see that?
Yes, sir.
Right, so my final answer is just y. So my final answer is just y. What's my gradient?
2.
Right, so
Positive 2.
right, so y is equal to 2x. Right, and my y-intercept is?
Negative 2.
That's it. I'm gonna follow you understand that.
Yes, sir.
Yes, sir.
Okay, good. Cool. Right? Let's move on. Show by calculation that line L and line M are perpendicular. So anytime you want to prove that two lines are perpendicular, you need to show that the product of their gradients is -1, right? So you need to show that the gradient of line M multiplied by the gradient of line M is equal to -1. That's how you show by calculation that the gradients that they're perpendicular, right? If the gradients are the negative reciprocal of each other and the product is -1. So there we go, right? Guys, and you already have the gradient of line M? Yeah,
Yes, sir.
Yeah.
right. The only gradient we need to find now is the gradient for line L. Who would like to volunteer to help me find the gradient of line L? I promise it's not hard.
I will continue, I guess.
All right. So Adika, do we already have a point that is on line L?
2, 2.
Yeah. And watch this, eh? Remember I said something, right? I said that what did I say about the point of intersection between two graphs?
That is the solution for the system of equations.
Yeah. So this over here is the answer for the simultaneous equations between line L and line M. You'll see what I mean by that very shortly. Don't worry. So yeah, we already have 2, 2. And are you seeing any other points along this line?
Um, 4 and 1.
4 and 1. Excellent. All right, so 2, 2, 4, 1. 2, 2, 4. Which one do you want to call the first point and which one do you want to call the second point?
We could call 2, 2 the first point and 4, 1 the second point.
All right, so M will be equal to, so y2 minus y1 over,
over x2 minus x1.
right. What is y2?
4. Wait, no, 1.
What's y1?
2.
Right? What is x2?
4 minus 2.
What's 1 minus 2?
Negative 1.
It's 4 minus 2?
2.
Ah, so I'm gonna ask that question, right, guys? If the gradient of line M, right? So we found out the gradient of line M was 2, right? This was 2. And we found the gradient of line L to be minus a half. Can we see that their gradients are the negative reciprocal of each other just by looking
Yes,
at it?
sir. Yes, sir.
Yeah.
Yeah, we could see that, right? Because if you flip 2 over 1, it'll be a half. And if you change the sign, negative a half, right? And
Yes,
remember,
sir.
at the start of class, on the start of this, we said, yeah, them looking like the perpendicular. So you see, look, we prove it. But if you want to prove it completely, you need to prove that their product is equal to minus 1. So the gradient of L is minus a half. So you're going to say minus a half. And I'm going to multiply that by the gradient of M, which is 2. What is negative a half times 2?
Negative 1.
Yeah, right? Because 2 into 2 is 1, and 1 by minus 1 is minus 1, right? Are you all confused or you understand?
I understand.
Faith, you're saying real quiet. So if you're confused, I need you to tell me. Otherwise, to tell me you're confused after. Way to tell me confused while we're doing
I'm
it.
confused.
Okay, good. Awesome. So let's continue then. Aaron, you good?
Yeah, so
Aaron, we're cooking, right? We're cooking. I'm no.
yeah.
Yeah. Right. So okay, look, I called it, guys. We called it. Anika, read on the last question.
Line L and line M represent the graph of a pair of simultaneous equations. Using the graph on page 11, write down the solution to the pair of simultaneous equations.
So waiting the answer for that is
Um,
so Adika, let me just tie in everything we learned so far, right? If a point is on the line, it will satisfy the what?
the equations, the two,
Exactly. Is there a point that would satisfy both the equations for line L and M?
yeah, 2 and 2.
That's it. That makes sense, right? Let us soak in for a second. Guys, 2 comma 2 is on both of the lines. If it's on both of the lines, then it will satisfy both equations. Does that make sense?
Yes, sir.
Yeah, that makes sense, right? Everything makes sense. So watch. Remember I said if a point lies on a line, it is supposed to satisfy the equation on the line. So if this point is on both of the lines, then it will satisfy both the equations. So your answer would be x is equal to 2 and y is equal to 2. Does that confuse you?
No.
Right? Point of intersection. Right. On to our next question. If nobody wants to help me, I guess Adika gonna go again at this point. Right? Adika, I don't really hear anybody, so like you want to continue?
Sure.
All right. So, B part 1. Using our ruler, draw the lines x is equal to a half, y is equal to x, and x plus y is equal to 5. Okay. Do you know how to do the first one? X is equal to a half?
Um, no.
Say that again?
No.
You sure about that?
It will be between
Wait
1
a wait
and
a.
0.
You sure about that? You sure about that? You sure about that?
Oh,
Remember, we did questions like that. If his x is equal to something, is that what kind
it
of
will
like?
be
So when they say
between 1 and
they
0.
mean 0.5 of the
Yeah, yeah. So like you see how we have 0 and 1? That would be a vertical line passing through the middle.
Yes, that would go like on the first grid on the x-axis.
Yeah, right here. Are we okay with that?
Yes, sir.
Yeah.
And I'll
Yeah.
put the equation. This is x is equal to a half. Now, onto a trickier one. Y is equal to x. Now, how much of you guys were there when we was doing 10-hour marathon, 10-hour live? Because we did things like this in 10-hour live. Okay, based on your
No,
setup.
I
I think I
wasn't.
was there.
All right. Well, let me explain something, right? If his y is equal to x, then for every value of x, y is the same. So let me show you how we could figure out this how what our line would look like. So again, the line literally says y is equal to x. So tell me if this making sense, right? At that point over there, would y be equal to x?
Yeah.
No.
It would. Watch.
It will be the same 1, 1.
Watch. The point would be 1, 1. So x is 1, y is 1. So wouldn't 1 be equal to 1? Wouldn't y be equal to x?
Yeah.
So when they say X, where the line starts,
Say that again.
the first line with where X starts, and not the answer we just got,
Okay,
as in the 0 point.
here it says 0, 0 is correct, right? But I'm just showing you the concept. I'm just showing you how to come up with the general shape of the graph. So 0, 0
Mhm.
1 as well. 0, 0 will be 1 as well, right? But I think everybody could see this point here. 0, 0 might be a
Yeah.
little bit more abstract, right? But if you look at this point, you can see, this point represents 1 is equal to 1, which is y is equal to x. Okay,
All right.
next point, feet. Next point, right? What about if I said this point over here? At that point, wouldn't y also be equal to x? Yes or no? Tell me, guys, at that point over there, wouldn't y also be equal to x?
It would.
Yeah. Yes, sir.
Okay, what about like over here, 4, 4?
Yep.
Yes.
So guys, I don't know if I see what again at, right? But this line is going to be like a diagonal line, right? Passing through all of these points that I just created. Let me know if you guys
Yeah.
let me know if you understood what I just did.
Yes, sir.
Because any point I take along this line, y is literally equal to x.
Yes, sir.
Exhibit A. Read off that point for me.
5, 5.
Exactly. And y would be equal to x.
Yes,
Yeah.
sir.
Yeah. Yeah. Right? Cool. Cool. Right? Onto this now. So x plus y is equal to 5. This one might be a little bit harder to see. But let me show you how we're going to do it. So first things first, I'm going to rearrange this in a form y is equal to mx plus c. Right? You don't have to, but it makes things really simple. Guys, if I put it in the form y is equal to mx plus c, then I have to make y the subject of the formula. If that's the case, what should I do with the x?
Carry it over to the negative x.
Right. And if I put it in a suitable location, it will look like y is equal to negative x plus 5. Did I confuse you all?
No.
And in this form, right, y is equal mx plus c. What is the y-intercept?
Five.
Yeah, the y-intercept is 5, right? So whatever it is, we're going to pass through this line. Now, the easiest way to do this question would be to find for the x-intercept, right, and the y-intercept. We already know what the y-intercept is. Now, let me just say something, right? And remember this. At the x-intercept, y is 0. And at the y-intercept, x is equal to 0. Please remember that. Please remember that, right? Please. I beg of you. Whatever you do, please remember that. So guys, we already have the y-intercept. Adi, guys, you already have the y-intercept?
Yeah.
So you got to worry about that. Let's find the x-intercept now. So you understand, I'm just trying to get 2 points here because for a line, and you can draw a line if you have 2 points.
Yes.
All right. So at the x-intercept, y is equal to 0. So I'm going to say 0 is equal to negative x plus 5. So I know y is 0. So if that's the case, I'm just trying to find for x. How would I find for x?
Make X the subject.
Right. Now there's an easy way you can do this, but I'll just stick to the standard approach. You probably move across 5. And you probably just move across 5.
Yeah.
Yeah, and you will get minus 5 is equal to minus x. What you will do next?
Divide.
Divide both sides by?
5 minus 5.
Yeah.
X minus X.
No. If you're doing this, you divide both sides by minus 1.
Oh.
Why? Because you're not seeing it, right? But this is understood to be negative 1x. So you divide by the negative 1 so that it cancels off. Yeah or no?
Yeah.
Let me show you something easier, right? What? Okay, if I had negative 5 and you wanted to turn that to positive 5, we're going to multiply by
Negative 1.
exactly. So you could multiply both sides by,
Negative 1.
yeah. And you're going to end up with 5 is equal to
1 for X.
x, right? So here what? If that is the case, my x-intercept would be at
5.
5, right? So that would be right here. So I'll just connect those 2 points. And that's it. Did you understand that?
Yeah.
So I'll go it over again because I feel like a lot of people did not understand that. And I will try to make it even simpler, right? Where we don't even have to put it in the form. So, Aaron, you there? Aaron, I'm going to know if you're there.
Yeah, yes. Sir.
So, Aaron, the 2 easiest points I would recommend you to find for is the x-intercept and the y-intercept, right? At the
Yes.
x-intercept, y is 0, right? At the x-intercept, y is 0.
The y-intercept x is 0.
Right. And we have an equation here that x plus y is equal to 5. So if we're dealing with x-intercept, right, I'm going to replace y with
X
0,
0.
right? So I'll say x plus 0 is equal to 5. So x would be equal to,
5.
so my point would be
5.
5, comma, what was the y value?
0.
Right. Easy, right?
Yeah.
Okay. And for the y-intercept, what's the x value?
0.
So anywhere I see x, I'm just going to write.
0.
So I will say 0 plus
Y is equal to 5.
so y is equal to,
5.
so that point would be
0, comma 5.
Okay, that easy?
Yes, sir.
All right, so do you understand that I placed the 0, 5 over here because y, that was the y-intercept.
Yeah,
And the x-intercept, I placed it over here, 5, comma 0.
yeah, I see it, I understand.
So you're completely good with these things. Come on.
Yeah,
All right, on to somebody that might be confused. Is there anybody that's like really, really confused? Danelle, talk to me, right? Did you
Yes,
know
sir.
did you know that the x at the x-intercept y is 0? Yes or no?
Yes, sir.
All right. So if this is the equation we're dealing with, right? If that is the equation we're dealing with, and we know y is 0, anywhere I see y, what am I going to write instead of y?
5, sir.
Nah,
0.
0,
0.
right? Because y is equal to,
0.
right. So instead of writing y, I'm going to write 0. And where's x plus 0?
X plus 0 is 5.
No, x.
X is,
X plus 0 is x.
okay.
I understand what you're saying, right? You're saying x plus 0 is 5. I get what you're saying. But just imagine if I actually is 5 plus 0. You can tell me.
0.
Nah,
5.
5, yeah. I'm not trying to trick you, no, I promise. I'm not trying to trick you. What is 8 plus 0? 8 plus 0.
8.
Right, so what is x plus 0?
X.
Right. So we end up with x is equal to 5. So my point then is x is 5 and y is 0. For the y-intercept, right? X is 0. So anywhere I see x, I'm going to write what instead?
0.
Right? So instead of writing x, I'll say 0. 0 plus y. What is 0 plus y?
0. 0 plus y is 0. Is y?
Y. Yes, yes, not 0. If I ask you what is $8 plus $0, would you tell me $0?
No, 8.
Exactly, right? Exactly. Do you understand how I came up with these 2 points?
Yes, sir.
Right, Faith. I want you to tell me, are you like real confused?
No, I'm not real confused.
Say, understand that the x-intercept y is 0 and at the y-intercept x is 0.
Yes.
Right, and from there, just plugging that into the equation they gave you to find 2 points. You need 2 points to draw a line. Okay, so here what? This is a linear programming question. This is a linear programming question, right? And I think it's a really good opportunity to introduce all to linear programming. All you think, are you ready for that step? Or no?
Yeah.
Okay,
Yeah.
all right. Making good headway, boy. Okay, nice. So just now we could look at the paper 3 question. So okay, so guys, this inequality here is saying that x has to be more than or equal to a half, right? More than or equal to a half. First things first, guys, ends up seeing equal to everywhere, like the symbol now. They know
Yes,
you.
Yeah.
sir.
All right.
Here.
So that would explain. I mean, here what that'd be real wicked if they said draw the lines first and then more than. That would be really upsetting because then you would have to take eraser and you would have to like erase all touches because remember, if it's more than or less than, enters like a dash line. Remember I said that earlier?
Yeah.
Yes, sir.
Yeah. So is equal to, so you just draw a solid line, right? Good. Now, if it is, let's start off with this one. And this one is really simple. So this one is more than or equal to a half. So I'm going to shade the area and I want you to tell me if you understand. It would shade over here. Can anybody figure out why I'm shading over here?
Because it's more than the half.
Because
The half line
it's
is more than.
one on the
Exactly. Because any line, anything I take over here, I watch x is 1, X is 2, X is 3, X is 4, X is 5, X is 6. Does everybody understand why I would shade over here?
Yeah.
They know. And here's something if you're confused. They're saying X is more than or equal to a half. So can you see that over here? X is more than a half?
Yes, sir.
You're sure?
Yes,
Like
sir.
real sure.
Not real sure, but a little bit sure.
Okay, well, we need to make sure you're real sure then. So then now, at this point over here, where's the X value? X is equal to?
Half.
Okay. Over here, where's X?
1,
Over here, X is?
2,
X is?
3,
The X value is getting smaller or bigger?
bigger.
All right. So if it's getting bigger, would I say more than or less than?
More than.
Right. So this symbol over here is more than or less than?
More than. Equal. Yeah, more
Exactly.
than.
So do you understand why I'm shading everything over here?
Yes, sir. Well, we had to go all the way up there, sir?
Here what? In this question, it just asks us to label the region R. So they don't want me to, shade all of that. They don't. They
Okay.
actually just want us to shade this region over here. But I just leading you up to that point now.
Okay. All right. That
But
part I was a little confused about, sir.
well, let me just shade the whole thing for you while I at it. Okay, is anybody confused as to why I'm shading this region?
Nope.
Do you understand that this entire region would be where X is more than a half? Yes or no?
Yes, sir.
Yeah.
Okay, cool. All right, so I hope nobody is lost. The next part, they're saying that Y needs to be what? Y needs to be?
More than
More
equal
than
to.
No, no,
equal, sir.
equal to X.
All right, let me show you guys how we're going to do this, right? So with linear programming, what you do is we typically take a test point in your regions. You take a test point. So let me show you what I mean by a test point, right? So guys, along the line itself, wouldn't Y be equal to X? And we figure that out, like along the line itself,
Yeah.
and Y is equal to X?
Yeah.
Yeah. So we need to figure out where Y is more than X. So we're going to take a point on either side of the line, right? So we can either take a point from here or here. But we need to pick a point that would satisfy the inequality. So I'll take a guess. Which region do you think the answer is? This region, region 1, or region 2? Pick a guess. So Y has to be more than X. Just pick a region. So this line cuts in the graph in half.
Region 1, sir.
Let me see, right? To test if you're correct, you're going to pick a point in region 1, any point in region 1. So can you pick a point anywhere over here for me? Any point? I feel like linear programming gonna come for this year. I don't know. I have a strong feeling. So I can pick any point here, Get creative, and you can pick any single point. Any single point.
6. 6 and 2.
Okay, if you say 6 and 2, 6 and 2 is in this region.
Oh, no, 2 and 6.
2 and 6. 2 and 6. So over here, right? 2
Yeah.
comma 6. What is X and what is Y?
X is 2 and Y is 6.
So, okay, I'm asking that question, right? What sign would I put in the middle? 6 is more than 2 or less than 2?
6 is more than 2.
And 6 is y, hence.
Yeah.
So guys, does this point satisfy the inequality? I want y to be more than
Or
x.
not.
Wait,
Oh, yeah.
yeah, it does. Watch. Guys, are you seeing what I'm talking about with the test point? Yes or no?
Yes. Yeah.
Awesome.
So guys, this we have the shade over here, right? But let me show you what will happen if you take a test point on the other region. So Faith, let's just say we take a test point from the other region, right? By the way, Faith, can you see that the graph here is cutting the graph into one region over here and another region over there? Can you see that? Okay, I'm not hearing from Faith, but do you all see what I'm talking about? That line there.
Yes.
It's,
Yes,
Yes,
sir.
sir.
it's cutting the graph, right? So somebody, I want you to read off that point for me. This red dot. Read off that red dot for me.
5, 2.
What is x here?
5,
5.
It's y,
2.
right? So okay. Remember, they want us to, we want to shade y is more than x, right? Tell me, guys, is 2, which is the y value, more than x, which is 5? Yes or no? Is 2 more than 5?
No.
No.
No. So will we shade this region?
No.
No. So all you understand how linear programming is work?
Yes, sir.
Yeah.
You're gonna take a test point, right? And you're gonna see which point satisfies the inequality, and that'll tell you which region to shade. That's how it works. So I'm gonna shade this region over here. Because if you take any point in this region, right, y is going to be more than x. That's the gist of it. Okay, do we understand everything so far? Yes or no?
Yes, sir.
Okay,
Yes,
and
sir.
the last one, we want to pick this was red. This was red. All right, so green. So here we're gonna do, right? We need to figure out where x plus y is less than 5. X plus y is less than 5. So I want you all to pick a region, right? And we're gonna test the region. Where do you think x plus y? Take a second, something just closed. Yeah, guys, I want you to pick a test region, right? X plus y is less than 5. Region 1 or region 2?
Region 1.
I hear everybody picking region 1. Yes or no? Do you all agree?
Yeah.
Okay, well, how would I test if that's true? How would I test if it's region 1?
Picking a
I would
point.
I would need to take a point that's over here in this region. So pick a point in that region for me.
1, 1.
1, 1. Is everybody okay with that? 1, 1?
Yeah.
All right. So in this region, x is 1 and y is 1 here, right? So it was x plus y, right? And for it to be correct, x plus y needs to be less than. For it to be correct, x plus y needs to be less than.
5.
Okay, x is 1 here and y is 1 here. Where's 1 plus 1?
2.
2.
Is 2 less than 5?
Yeah.
Yeah. So can I go ahead and shade this region?
Yes, sir.
Yeah. Now, if I take this, if I already have a point here, right? Let's test that point and see what would happen. So again, for us to be able to use the region, x plus y needs to be less than 5. What is x over here?
5.
5,
What is y over here?
2,
Okay. Is 5 plus 2 less than 5?
no,
Because what is 5 plus 2?
7,
7 less than 5 years?
no,
No. So I cannot shade this region. Does everybody understand why I'm going to shade this region?
Yes, sir.
yes, sir.
Okay, cool. I was kind of worried to show the linear programming, maybe although I get confused, but it seemed like I understand this thing. That's good. This is really give people trouble, by the way. All right, so we agreed that we would shade this region. Are you all seeing a region where everything is shaded by chance? Yes or no?
Yes, sir.
I make this like a yeah. Are you all seeing a region where everything is shaded? Like absolutely all like the shaded regions are overlapping? Yes or no?
Yeah,
Yes, sir.
Yeah.
Yeah. And that region is over here. How many of you agree or not?
Yeah.
Aaron, you agree?
Yeah, so
For one mark question, it's kind of ridiculous. But I mean, if you like, I saw it immediately, right? Like when I looked at this, I saw it immediately. So I think I'll make it reach that point. So this is R. Do you think it's like insanely hard, or like you could manage it? What do you think?
it's manageable.
I think you're manageable.
Okay, cool. Awesome. So we just looked at linear programming. Yay. So here what? I want to do probably 2 more line questions, right? And at 10, we should be finished with lines and linear programming and be ready to move on to vectors, right? Nice. And at 12, we should be more or less wrapping up with vectors. So tomorrow we could just do the last remaining topics, which if it goes to plan, right, would be matrices, statistics, measurements, consumer arithmetic, and number theory and computation. Like the easy stuff. The only thing I might take a little while for me to show you is angles, like when constructing angles. Do you all know how to construct angles?
Um, I was using the half circle thingy.
Yeah, the protractor.
Oh, yeah. So, let's have a question in the paper too that is we like a plane travel on a certain amount of bearings at this time, and then you had to like calculate the time it reached. What topic is that?
That's kinematics. That's speed time graph. It's not like it's tying it up with bearings, but to not come in January 2023. No, I know what you're talking about. You're talking about distance time graph and speed and you're talking about displacement time graph and speed time graph.
Yeah, so you will be doing that or no?
Yeah, we do the whole syllabus. And if we don't finish, I'll go over a day. It's fine.
Oh, okay.
I want to see how they pass, you know. Well, they had to pass the exam, right? Okay, give my year. Pick a year, guys.
2023.
Okay, we just do that. Maybe June.
Yeah.
We just do that as well.
2024.
We already do that. Yeah, we already did that.
2021.
Imagine
Don't do multiple choice.
imagine we already did that. Wait,
2018.
I say, imagine if we already did it. I'm not sure if, yeah, we did do 2021. Actually, oh no, look, we didn't do it. All right. Yeah, let's do this quickly. So, yeah, guys, give us a rate more. Somebody, give us a rate more.
The diagram below shows two lines L and L2. The equation of the line L1 is x plus 2y equals to 10. The line L2 passes through the points 0 and -5 and is perpendicular to line L1.
Right? They want us to express the equation for line 1 in the form y is equal to mx plus c. So they're giving us the equation as x plus 2y is equal to 10. Right? Right? So x plus 2y is equal to 10. Is there any form y is equal to mx plus c?
No,
No. So we need to make y the subject of the formula. How would I make y the subject of the formula?
you will carry over the x, so it will be x minus 10.
Be careful, eh? It's going to be minus x plus 10.
Yeah,
Because the positive x going to turn into minus x, and well, it was positive 10 before, so plus 10. All right, what next?
divide.
Right. Now, I want you to be real careful with this, right? Now, normally, under normal circumstances, you would just divide by 2 like that, yeah? And you would do that.
Yeah, yeah.
Oh, wait, I'm going to show you what I want you to do. I want you to divide everything by 2 separately because we want it in a specific form. So the 2's will cancel off to give me y, right? This is going to, again, you're not seeing it, right? But this is minus 1x. So that's going to be minus 1 over 2x, right? And what is 10 over 2?
5.
5. Yeah, is there anybody that did not understand that at all?
No.
All right, let's move on. Now they want us to state the gradient of the line L1. State the gradient of line 1. So what's the gradient of line 1? If you compare this to the form y is equal mx plus c, what
The
is the gradient?
negative a half.
Right. M is equal to negative a half. Right. They say, and hence determine the equation of the line L2. Now, to find the equation of a line, you need the gradient and you need a point on the line, right? So we know that these two lines are perpendicular, yeah?
Yeah,
And we know that the gradient of line 1 is,
negative a half.
So the gradient of line 1 is negative a half. What do you think the gradient of line 2 would be? Since it
Mm, 2?
yes, excellent. It would be 2. And do we have a point on the line?
Yeah.
Actually, what would I call this point? As the what?
The y-axis.
And the
No,
y,
the y-intercept.
right. So this line is cutting the y-intercept at what value? Wouldn't be 0, eh?
0 or
Would not be.
-5.
Let me explain something. This value is the what value? X or y?
The x.
And this is the y. So this is -5. And again, if you say 0, right? And we know that this is 0.
Yeah.
If this line is below 0, it has to be negative something. So think about that. So my equation would just be y is equal to my gradient, which is 2, by x, and my y-intercept is
-5.
right. So that's my equation. Easy or hard,
Easy.
right? Hence determine the equation of the line L2. Oh, well, we just do that, right? That was the question we just did. My bad. This question was way too easy, man. Wow. This question was ridiculously easy. Yeah. All right.
So I wouldn't come off, right? I only hear things way after my wife like giving a lot of trouble because of the rain.
All right. Um,
You hear me?
yes, I'm hearing you. Mhm. Do I feel I'll give in trouble?
All right.
All right. You will let me know if the internet connection gets better. If so, join back. All right. So, guys, let me get some tricky questions when it comes to lines, and then I want to move on. So, lines. So, I have some questions here. All right, so let's raise things up a notch, right? Let's raise things up a notch. So, Adika, let's look at a perpendicular bisector question, shall we?
All right.
Things are going to get a little tricky. Do you remember what the perpendicular bisector is?
When it's meeting each other, the two lines meeting each other and it form 190 degrees.
You have half of it. Half of it. Look at this. The perpendicular bisector is the line that cuts another line in half at a right angle. So if you had a line segment AB, right, the perpendicular bisector would pass in the middle of it at a 90 degrees. Yeah or no?
Yeah.
Okay. So let's give this question a shot. All right, so Adika, good luck. Give the question a read now.
The points A, 2 and -3, and B, 8 and 3 are the endpoints of a line segment. Find the coordinates of the midpoint M of AB.
How would I find the midpoint?
Um, that is x2 plus x1 divided by 2,
Yeah.
and then y2 plus y1 divided by 2. And if we're cutting it in half,
right? Now, guys, if I say x1 plus x2 or x2 plus x1, is that any different? Will I get the same answer? Tell me.
Yeah.
Tell me, guys, if I have x1 plus x2 versus x2 plus x1, am I going to get a different answer? Am I going to get the same answer?
I get the same answer.
Right. So if you look it up online, right? If you look up the formula online, you are going to see this, right? You're going to see x1 plus x2 over 2, y1 plus y2 over 2. But I needed to understand that if you had x2 plus x1, you'll get the same answer. So it's fine. Because addition is what? What's the specific way we're looking for? So that's what C. Okay, I'm not hearing it, right? But commutative. Commutative. Doesn't matter in the order in which you add. All right, so Atika, let's proceed. So which point do you want to call the first point? And which point do you want to call the second point?
A could be the first point, so and B could be the second point.
Right, so then I'll say x2. What is x2?
8
Right, so that'll be 8 plus,
plus 1,
8 plus 2.
or
What is y2?
3 plus negative 3. And now be 0.
Right, so my points are going to be 8 plus 2 is 10, 10 over 2 is 5, and it's going to be 0. Do you have trust issues?
Yeah.
All right, so let me show you.
By using calculators, and the answer is 0.
Let me show you how this would look like graphically. So to pay in mind at least, right? Now, if I say is the midpoint, then it should be at the middle, yeah?
Yeah.
All right. So I'm going to put on a point 2 minus 3. Right? And I'm going to put on a point 8, 3. I'm going to connect these two together. Where's my graph? Yeah, I'm not sure where it went. It's giving trouble. Right? 2. Okay, what, we just have a settle for seeing it in the middle, right?
Yeah.
8, 3. Right, so that's A and that's B, right? If we are correct, our point should be in the middle, yeah?
Yeah.
And we got 5, 0. Does it look like it's in the middle?
Yeah.
Awesome. Now they want us to find the gradient of the line AB. So what's the gradient formula?
Y2 minus y1 over x2 minus x1.
Right, what is y2? You already labeled this already. So what's y2?
3 minus negative 3.
In brackets, right?
Yeah.
What is x2?
8 minus 2.
What is 3 minus minus 3?
6.
Right? 8 minus 2 is?
4.
You sure?
Oh no, 6.
6. What is 6 over 6?
1.
Right. So the gradient is equal to 1. I mean, if that confuses you.
Nah,
All right.
I
Not
understand.
so wait, do you understand at this point will be E? Let me draw a little graph. This is E, right? This is B. And the midpoint is in the middle. Yeah.
Yeah,
And the perpendicular bisector would be
passing through that.
at a right angle, yeah?
Yeah,
And we found the gradient of this to be AB.
1.
So if they are perpendicular, what the gradient for the other one will be?
Negative 1.
Yeah, because 1 is the same thing as 1 over 1, and
Yeah,
negative 1 over 1 is just negative 1. Awesome. So hence determine the gradient of the line perpendicular to AB. We already found that. That will be equal to negative 1, yeah?
yeah,
Right? The perpendicular bisector passes through the midpoint. We know that. And we know that.
yeah,
Use y minus y1 is equal to m by x minus x1 to find its equation in the form y is equal to mx plus c. In CCXC, they will never specify that you have to use the slope point form. So you could just use y is equal to mx plus c. Let me show you what I mean. By the way, did you guys ever see the slope point form before? Yes or no?
no,
All right, well, I wouldn't confuse you. Just use y is equal to mx plus c and right, use y is equal to mx plus c. So, Adika, so far, we know what the gradient of the perpendicular line is, right?
yeah,
Yeah. So here it is. We want to figure out the gradient and the purple line here. This is what we want to figure out. We already know its gradient. Do we know a point it's passing through?
yeah,
What point does it pass through? Remind me.
5 and 0.
So do we have a point that is on the line itself?
Yes,
Yes. So look how we're going to do, right? So we know that the gradient is equal to negative 1. We also know that we have a point, and the point is 5, comma 0. So that would make x and x what? What's x?
x will be 5,
Y would be?
0,
Right. So you're going to plug x and y and m, and you're going to find for c. So anywhere I see y, I'm going to replace it with.
0,
Anywhere I see m, I'm going to replace it with.
negative 1,
And anywhere I see x, I'm going to replace it with.
5,
And I don't know what c is, so I'll leave that blank. What is minus 1 by 5?
4,
Nah, nah.
minus 4.
Multiplying, eh? You're not multiplying.
It will be minus 5.
Exactly. Multiplying. Don't make a mistake in your exam. Eh? Again, if you're having a hard time and you don't trust yourself, use a calculator. Eh? Yeah, that calculator for a reason. Make sure you make use of that. Make sure you make use of that. So yeah, again, if you have trust issues, put minus 1, multiply that by 5, and you'll see minus 5. Yeah?
Yeah,
Okay, and how would I find for C?
make it the subject,
Right. So what shouldn't be on the right-hand side then?
minus 5,
Right. So if I move the minus 5 across, I would enter.
positive 5,
So C is equal to?
positive 5,
Right. So here what? If we know what the gradient is, and we know what the y-intercept is, what is my final equation? With
um,
I will show you how easy this is. So remind me, what is the equation of our line?
Y equals mx plus c.
Right, what is m? What do we find m to be?
-1
Right, so negative 1x. Uh-huh. What do we find?
plus 5.
Exactly. Right? Right. Then in part E, they are asking us to state why this makes, okay, state what makes this line a bisector and why it is perpendicular to AB. Right. It is a bisector because it passes through the what?
E.
See if you can figure that out. Bisector cuts something in half.
It partially perpendicular line.
Yeah. It passes through the midpoint.
Oh yeah.
Right? And it's perpendicular, right? Because the gradients it's perpendicular because the product of the gradients is equal to -1. So this is a question that could come in the exam, perpendicular bisector. Right? So just putting that out there. All right. Yeah, guys. So I'm gonna add in a third question into this. On the third question, I don't know what question that'll be. Let's call it F. Right? Find the length of the line segment AB. Guys, how would I find the length of a line? Tell me, guys, how would I find the length of the line segment AB? What's the formula for length of a line?
Square root. It will be square root in brackets x2 minus x1 squared plus y2 minus y1 squared.
Right, so can you tell me what x2 is?
8.
8 minus, where's x1?
8 minus 2
Right, 8 minus 2 squared.
squared plus 3 minus -3 squared.
Right, so 8 minus 2 is
6.
6. And for some reason, I tell me to say 4 as well. I don't know why. 8 minus 2 is 6. 6 squared is,
36.
right? Okay, let me take my time with this one, right? So minus is plus. So 3 plus 3 is,
6.
I'll be honest, I was tempted to say 9. I don't know. Right, 3 plus 3 is 6, right? And 6 squared is,
36.
right? So 36 plus 36. I'll be 72. What is the square root of 72? Come on, the two decimal places.
8.49.
Right? And you don't know what it, you know the measurement, so just say units. Let me just verify that. 8 point, yes. Hey guys, so we are done with coordinate geometry. Yay! Right? And we understand linear programming. So here what? Let's look at that paper 3 question now. Even if you aren't doing paper 3, this is still good preparation for what could come in paper too. Right? So there we go. All right, guys, so let me start off relatively easily, right? We're going to start off relatively easily. All right, so who would like to volunteer to do this question with me? I promise it's not hard. Somebody other than Adika, please. Adika, okay, Aaron, you there?
Yeah, sir.
Okay, Aaron. Aaron, let me attack this thing, right? Yeah, so Aaron. Um, so we have 3 lines here. Can you make out the 3 lines?
Line, I want to say line L1,
Right?
um, then the line from 5 coming down, and line L2.
Awesome. So you're saying 3 lines, right? Now, this is a region in common, yeah?
Yeah,
So I have a question. Think to yourself. Would you have shaded this side for line 1? Or you'd have shaded this side? You take a guess.
so you want me to be really honest.
You don't know.
So I probably would have leave this question. Graph something used to scare me back in the day. I probably would have leave this question out entirely. I wouldn't even bother sheeting it.
Okay, Aaron. But this times have changed, right? You're gonna see
Yeah.
what this thing is, right? Okay. So I need you to come into this with an open mind. Right? Please come into the open mind and you see how simple it is.
Mm-hmm.
All right. So I want to do 3 linear programming questions. Is I have what you were looking for, a hunch that's gonna come. Right? After we finish with all the linear programming questions, what we're going to do, I'm gonna give all like a 20 minutes break. Right? We're gonna come back and we're gonna grind vectors. Yeah, we're gonna grind vectors. All right, so Aaron,
Yeah.
let's look at the table here, right? So they're telling us that the equation for line 1 is y is equal to 2x. So let's put that down. The equation for line 1 is y is equal to 2x. The equation for line 2 is y is equal to 2. And Aaron, no, we're not leaving this out, eh? We're going to get our marks.
Yeah, sir.
By the way, Aaron, I'm curious. What school you're from? Because it sounds like you're real smart. It's just that the teachers don't teach properly.
So I'm from Holy Cross College, sir.
Holy, it given holy name convent. Is it like the brother school for that?
No, is in Arima, sir.
Arima. Oh,
Mhm.
I
So
never.
I wrote CSEC in June. I passed everything except for maths, so I had a
Oh, oh, I see. But like just by talking to you, probably would not, I probably would not think you feel much. I mean,
yeah. Well, maths is because maths was the only subject that had the not so good teachers.
damn, baby. I know you guys, eh? I haven't asked like the evening or like the day before the exam. I'm gonna have a session, a free session. Anybody could join, and I'm just gonna help all with absolutely any question I have.
Okay,
Absolutely
sir.
anything. All right. So, Aaron, you're going to get this correct. This is very easy. I swear to God, it's so easy. Right, so we need to figure out the inequality associated with line 1. Now, if this is a region in common, right,
Yeah.
then obviously, wouldn't this region have to... Okay, let's look at our previous question, right? And that will kind of show you what I'm talking about. Something I did before. You kind of familiar with. See if I can find it. Which question was that, bro? I know we just do a question, you know.
It was in 2023, sir.
It's 2021. Right. Look at this, right? Check this.
Mm-hmm.
If this is a region in common, right?
Yeah.
And it would have to overlap with all the regions.
Yeah.
So watch. Right? See what I'm talking about?
Yeah. Seeing.
So I want to apply the exact same concept over here, right? Exact same concept. If this is a shaded region, right?
Mm-hmm.
Do you think I would have had to shade it in this region? Or this region? 1 or 2?
I think 2, sir.
I think 2, because if you shade over here, right? If you shade over here, how are you going to get a common region?
You won't be able to.
Let us soak in here on. How will you get a common region, right? Because if you're shading over here, will that ever overlap with this?
No, sir.
Nah. Adika, does that make sense? Hear what I'm saying, right, Adika? If you shade over here, right? Will that overlap with this?
No, sir.
No. Right? So you would need to shade over here. Are we confused? I want to tell me now.
No, sir.
No, sir.
Okay, word. So guys, can you see already that if I shade there, it's kind of it's overlapping the common region? Yes or no?
Yeah.
All right. So Aaron, the next part, we figured out where to shade, but we need to figure out what inequality that would correspond to. So to do this, Aaron, I want you to select a point that's in this region. So select any point that is in this region for me.
6, 3, sir.
Okay, 6, 3. Sure. That's correct. 6, 3. 6, comma, 3. So X is what?
X is 6.
And Y is?
3.
All right. And the equation or the line is Y is equal to 2X, yeah?
Yeah.
All right. Look how we're going to do, right? Y is what?
Y is 3.
X is?
6.
Right? Where's 2y6?
12.
What inequality sign you would stick in the middle here?
Um, less than, sir.
Yeah,
Less than or equal to.
yeah. So that's that. Look at that was easy, right? Aaron, tell me that was easy.
Yeah, it looks easy, sir.
Right? Now I have to be careful, eh? I'm not going to just put less than, I'm going to put less than or equal to. Because the lines that they draw, was it solid or dashed?
What is that?
I can't just put less than, I need to put less than or equal to. Why? Because the lines that they drew was solid. See now? It wasn't
Yeah.
dashed. All right, so Aaron, you're on a roll now. Let me see if you can figure out the next one, right? Okay, so now we need to figure out the inequality associated for y is equal to 2. All right, so this is y is equal to 2 over here, right?
Mm-hmm.
Okay, if you wanted to overlap with this region, will I be shading over here, region 1, or will I be shading region 2?
Region 1, sir.
Yeah, you could see that, right? You could see it. Making sense?
Yeah.
Right, so our way to pick a point anywhere in that region. Where
Um, 4, 2, sir.
4, 2.
Mm-hmm.
If you pick that point,
Yeah.
right, that is along the line y is equal to 2. So like that would be y is equal to 2. It would not be, it wouldn't be more than or less than. But like,
Oh, okay.
well, like this one real simple though, you're on. Watch this, right? If this is
Mm-hmm.
equal to 2, right? If that is y is
Yeah.
equal, and we shade over here. We shade in where y is what? Where y is what?
Well, y is equal to 2.
Watch. Again, this is y is 2, right? And we
Oh, we
shaded,
shade where y is more than 2.
yeah, seeing that, right?
Yeah.
Y is 3, y is 4, y is 5, right? So we are shading, right? Where y is more.
More than 2.
Make sense?
Yeah.
Probably saying, wait, why are leaving all this easy marks? Damn, damn. Right? So y is awesome, right? And Aaron over here now. And we see that they gave us the inequality for the line,
Yeah.
and we want to find the equation. You know, there's a trend about the other so far. The
Uh,
equation and the inequality is like, is it the same thing?
yeah.
It just have a what in the middle.
It just has an equal sign in the middle.
So what do you think that's gonna be here?
2y is equal to 10 minus x.
But if you look at the in brackets, say what is in what form?
Huh?
If you look inside the brackets here, what form do they want it in?
The equation, the form y is equal to mx plus c.
Is this any form y is equal to mx plus c?
Yes.
Nah. In this form, do you see anything but the y?
2y, sir?
No, like in this form, right? In the form of do you see anything by the y?
No.
No. So it should just be y. We need
Oh,
to
okay.
find subject. So we divide both sides. We divide both sides by,
By 2.
and I'm going to do it separately, right? Right? So I'll end up with y. Right? 10 minus 2 is, 10 over 2 is,
5.
right? This is the same thing as minus a half x. Or that confusing you?
It kind of confusing.
All right. So I'm gonna ask that question, right? If you have x over 2, so figure out what in the sign, right? X over 2.
Mm-hmm.
It's the same thing as x multiplied by what fraction?
A half?
Yeah. Watch. So if it's negative x over 2, that's just minus a half.
Oh, okay, I see it. See it now.
Okay, good. So that's the answer.
Oh, okay.
It's the answer. Right? One thing I'll do though, I'll take this and I'll switch it around. So I'll say minus a half x plus 5.
Okay. But if you leave it as y is equal to 5 minus half x, you'll get wrong.
Yeah, I get wrong because they wait in this form.
Okay.
Right? I mean, if you fully understand this.
Let me just take a screenshot, sir.
All right, take a screenshot there. What do you think though? You think linear programming hard or like manageable?
I think it's manageable, sir. I got the screenshot.
Okay, nice. Adika, I want you to tell me what you think about linear programming.
So I thought it would be harder.
I tell you, right?
Sometimes, yeah. It's just the inequalities that is giving trouble sometimes.
Noted. So here what Arika, let me do a question, huh? Let's do another question.
Okay.
Let's do another paper tree. So Arika, this one a little harder, eh? Which one? Yeah, this one, I just put one in here, right? This one a little harder. Okay?
Okay.
All right, so Adika, it's a similar concept, right? Can you see that we have a line one here? This is a line one,
Yeah.
all right? All right. In the table, do we have the equation L1?
No.
No. Do you think it'll be hard to figure out though?
No.
No. If you look at L1, do we know what the y-intercept is already?
Yes.
What's the y-intercept?
By 6.
6. Now, the y-intercept is where a line cuts in the y-axis. Where's it cut in the y-axis at?
Oh, just oh, 2.
Right. So for line 1, automatically, c is equal to 2. Tell me that confusing.
Nah.
Right. So the only thing you need to find for now is the what?
The x
Nah,
gradient.
the gradient, yes, because it's a line, right?
Okay.
So pick 2 points along that line for me.
Um, I can't see the x. You could scroll down a little bit. Okay. 4 and 6.
4, 6. Yeah, yeah, 4, 6. Mm-hmm.
Um, 5, 8.
5, 8.
That could work.
5, 8 would be over here. That wouldn't be on the line.
Or nah, it will be 6, 8.
Yeah. So which one you want to call the first point and which one you want to call the second point?
We could call the first point 6 and 8, and the second point will be 4 and 6.
I said the gradient would be what? I mean, what's the gradient formula?
Um, y1,
Nah. Hmm.
y2,
Right. Y2 minus.
y1 over x2 minus x1.
Yes. What is Y2?
6,
Yeah. What is Y1?
8,
Right. 8. What is X2?
x2 is 4 minus 6,
Right. What is 6 minus 8?
-2 over -2.
What is -2 over -2?
1,
So my gradient is,
1,
or y-intercept is,
2,
right. So my equation from the line is,
y equals 1x plus 2.
yep. You understand that completely?
Yeah.
Right now we need to figure out the inequality. So let me ask that question, right? If this is the region in common, right?
Yeah.
Do you think I'll shade it on this side? Or do you think I'll shade it on this side?
You shade it on one.
Exactly, because if I shade it in this region over here, how will that ever overlap with this? You understand?
Yeah.
But that cannot prove, wow. Right. So you okay with what I shade, right? Yes or no?
Yeah.
Now we need to figure out what inequality that would be. So to do that, I want you to pick a test point. So pick a point in that region, somewhere over there.
Um, 8 and wait, it's either be on the line or is
No,
any part in it shaded?
not on the line. Not on the
Oh,
line. Right? So when we're doing this one, you gotta pick a point somewhere over here. Anywhere over here.
oh, okay. It could be 8 and 2.
8 and 2, sure. So if you pick 8 and 2, right? Tell me, what is that real hard to see? Right? 8, comma 2. Where's X and where's Y?
X is 8 and Y is 2.
Right. So, and the equation and the line we came up with just now is,
Y equals 1x plus 2.
I'm gonna show you how this is gonna go, right? So I'm gonna leave the equal sign out of this, right? You'll see what's gonna happen. Where's Y?
Y is 2.
X is,
8.
so 1 by 8 plus 2. Where's 1 by 8?
10. 8
You say the answer one time. That's fine, 10, right? So let's start to fill in the inequality now. 2 is what than 10?
less than
And did they use dashed lines or solid lines for the lines?
solid.
Right? So it's gonna be equal to as well. So my answer is gonna be Y is less than or equal to 1x plus 2. Easy or hard?
Um, it's easy.
It kind of in the middle. It sounds like it's not like it's
Yeah.
in the middle. More practice and you'll get it. For sure. Okay. Right. L2 now. L2. So let me use a different color for L2 now. So that's L2. So my first things first, obviously in the y-intercept.
Yes.
What's the y-intercept?
8.
Right, so the y-intercept is 8. But do we know what the gradient is?
No, but this line, no.
Now, so we need to find the gradient. So we need 2 points on the line. Pick 2 points on that line for now.
Um, 12 and 2.
Right, so 12, 2. Yeah, that's our point. What are the points to see on the line?
Um, 8 and 4.
Yep. Which one you want to call the first point, and which one you want to call the second point?
We could call the first point 8 and 4 and the second point 12 and 2.
So my gradient would be
y2 minus y1 over x2 minus x1.
And that will do what?
2 minus 4 over 12 minus 8.
2 minus 4 is,
Negative 2.
and 12 minus 8 is,
4.
minus 2 over 4 is,
0.5. Negative 0.5.
so negative a half.
Yeah.
Yeah. So I'm asked that question. We have the gradient and we have the y-intercept, right? So what's the equation at the green line?
Y equals mx plus c. So
Right.
will be y equals negative a half plus, well, x plus 8.
Right. And think to yourself, where would it make sense to shade? If I want to overlap this region or the other region?
It'll be 1.
A1, right?
Yeah.
Cool. Yeah, I don't know if you're okay with this,
Yeah.
right? So we need to pick a point in that region now to figure out where's the inequality. So pick a point for me in that region.
Um,
Right?
6 and 3.
6 and 3, right?
Yeah.
Right. And what was the equation we came up with?
Y equals negative a half x plus 8.
Right? So here we're going to do, right? We're going to forget about the equal sign for a bit, right?
Yeah.
We don't know how the processes go. What is x and what is y?
So it'll be y negative a half multiplied by 6 plus 8. Oh
What is,
yeah, it'll be
so negative a half by 6 is?
negative 3.
Negative 3 plus 8 is?
5.
Ah. So let's fill in the inequality signs now. Is it more than, less than?
Less than.
3 is less than 5. It was a solid line they gave us, so it'll be less than or equal to. I don't know if you understand that.
Yeah, I understand.
So you'll say y is less than or equal to minus a half x plus 6. So it's looking hard, but like, is it really, really that hard?
Nah.
Ah. All right, so guys, let's just run through the general procedure, right? First things first. In most of the times on these graphs, yeah, it's easy to find the y-intercept. So read off y-intercept. Read off y-intercept. Right? And this is C. What's the next step, Adika?
So find the gradient.
Right? Find gradient. M, right? What next?
So find the x. Find x.
Find the what?
Find x and y.
Wait, after this, you're gonna write the equation, right? The equation in the form
Y equals mx plus c.
right. Then we're gonna figure out which side to shade. Figure out which side to shade. From here, you're gonna select a test point. Select a test point to see the inequality, to see which inequality to use. If you understand that.
Yeah, I understand.
All right, nice. So that's that. Awesome. Now, you might get a little lost over here, right? So Adika, get that read from me.
A toy manufacturer makes X phones and Y trucks. The cost to make a phone is $75 and the cost to make a truck is $200. The shaded region R in the diagram on page 6 represents the only possible number of toy phones and toy trucks the manufacturer can make. Using the graph, determine the number of phones and the number of trucks which give the greatest possible total cost of production. Write down this greatest possible total cost of production.
Okay, that was a lot, then.
Yeah.
Okay, on a scale of 1 to 10, how much did it confuse you?
Not really, the answer will be 200 or no?
Let me see. So here what, right? The toy manufacturer making X number of phones and Y trucks, right? How much does it cost to make a phone,
Oh, $75.
right? So $75 would be the cost, right, for a phone. And the variable that represented a phone is X. So X number of phones, right? What's the cost to make a truck?
200.
And what's the variable we're using for trucks,
Y.
right? And that is telling us the number we make, right? The number. The shaded region, right? The shaded region represents the only possible number of toy phones and toy trucks the manufacturer can make, right? So we want to figure out the greatest possible total cost of production. So let me show you what happened in here, right? Can we see the shaded region?
Yeah.
If you want to figure out the most extreme cases, right there, let me show you something. Yes, I was saying, if you want to figure out the most extreme cases, what you want to do, right? Anytime you do linear programming questions, it's going to have to do with something related to the shaded region. So, Adika, can you see that shaded region over here?
Yeah, R.
So the most extreme possibilities are going to be given by the vertices. So we're looking at this vertex, we're looking at this vertex, and we're looking at this vertex. Now, I'm saying this because we want to figure out the greatest. The greatest. If it's the greatest, then it's one of the most extreme possibilities. So we're going to look at the vertices, right? Just remind me, X was the number of,
Phones.
right? Over here, I'm going to put number of phones. And y was the number of?
Trucks.
Right. Awesome. I'm talking about the axis and not the point. In case you get confused by that. All right, so my question is, right? What are the points? So tell me what this point would be.
It would be 0, 2,
Right? 0, 2. So that would have meant that we made 0 what?
0 phones.
And
Wait, no,
they are
0
0,
trucks.
0 phones and 2 trucks. Right? Because remember,
Oh, yeah.
10 trucks. Right? This point would be 4, 6. Yeah.
Yeah.
So if that's the case, I would have made how much phones?
4 phones and 6 trucks.
Right? 4 phones and 6 trucks. Okay, cool. And over here now,
You would have made 12 phones and 2 trucks.
and I'm trying to figure out the greatest cost of production, right? So what's the most amount of money I could spend? Yeah.
Yeah.
Right. So let's look at, so this is condition 1, this is condition 2, and this is condition 3. If we are looking at condition 1, right? If we are looking at condition 1, right? Where it is 0, 2. Again, that would mean that we made 0 trucks, 0 phones and 2 trucks, yeah?
Yeah.
Right? So 0 phones and 2 trucks. So what would be the cost there?
The cost will be $200.
Not
Wait,
quite,
no, $400.
right? So cost, that would be equal to 2 multiplied by 200, which would be equal to 400. Why? Because, well, I made 2 trucks, right? I made 2 trucks. All right, let's look at the second condition. All right, 4, 6. Over here now, I made how much phones?
You make 4 phones.
All right, so how much would it cost altogether to make the 4 phones?
300.
And let's verify that, right? So that would be 4 by 75, because 1 costs 75 when making 4, right? And I'm adding that to 6 by 200 to make 6 trucks. How much that would cost?
That would be 1,200 plus 300, so 1,500.
Wait, I mean 100. What's 4 by 75?
300
Okay, so
plus,
300 plus
yeah,
1200.
yeah, so 1,500.
All right, and let's look at the third condition. The third condition, you'll be making how much phones?
12 phones,
How much trucks?
3 trucks.
All right, so that would be 12 by 75 plus 3 by 200. What would you get?
900 plus 600. That would be 1,500.
The same answer I got? Yeah, that sounds correct. Let me just verify that. I'm verifying that on my watcher. Because my watcher was calculating on it. So 4 multiplied by 75 Yeah, that looks correct. Right, because 12 by 75, 900, right? Plus, okay, yeah, that's correct. So Max, that question, right? What is the greatest cost of production?
1500.
Oh, we made a mistake. I just asked 12.3. I don't realize why there was a mistake. This is 12.2.
Oh,
Yeah, it's like that kind of sus, you know? So check that back.
it'll be 1300.
Right? So to get the greatest cost of production, I would need to make how much phones? Four
You
phones,
will need to make 4 phones and 6 trucks.
right? How much it would cost?
It would cost 1500.
Ah, boy. What do you think about the question?
It wasn't that hard.
Right? I know, right? It wasn't that bad, right? It wasn't that bad. Aaron, what do you thinking now? Like, it was that bad, or like, what do you think?
I think it's manageable now, so
I think so, right? You could definitely get us correct, Aaron. Don't leave without me examine. I'm looking at it. Don't leave without me.
I won't say I won't.
At least try something. Otherwise, Timon will find you. Timon, then take a find him. Right now, Timon engrossed in that game. Yeah, but that's it for that. Let's do one more linear programming question. Right, I'll give a break, and then we'll mash up vectors. Yippee. Okay, guys. Who wants to help me with this question? It's a full question, right? Full question. Wait, yeah, do I have any volunteers? Any, oh, Aaron, I'll call you. Aaron. Last, linear programming question, 29, right?
Yeah, so
Right, so yeah, Aaron, give it a read from her.
a farmer supplies his neighbors with X pumpkins and Y melons daily using the following conditions. First condition, Y is more than or equal to 3. Second condition, Y is less than or equal to X. Third condition, the total number of pumpkins and melons must not exceed 12.
Wait, So, oh, look, they're asking us what the third condition one time. So yeah, you tell me, how would I translate this into maths?
Um, X, Y, less than or equal to 12. X plus Y less than or equal to 12.
Because it said total. Total means odd, right?
Yeah,
Nice. And it must not exceed 12. Must not. So it could be less than or equal to 12. Nice.
yeah,
Using a scale of 1 centimeter to represent one pumpkin on the x-axis and 1 centimeter to represent 1 melon on the y-axis, draw the graphs of the three lines associated with the three inequalities. Right? Identify by shading the region which satisfies the three inequalities. Determine from a graph the minimum values of x and y which satisfy the condition. Sure. So Aaron, now we try to handle this thing skillfully, right? So first things first, they want us to already with the label, right? So they want us to plot all of the inequalities, yeah?
Yeah.
So the first one is y is more than or equal to 3.
Mm-hmm.
So to the plot that, I'm going to put down the line y is equal to 3 first, right?
Okay.
3. And then I'm going to shade the appropriate side.
Yeah.
So y is equal to 3. Do you think that's a horizontal line or a vertical line? Y is equal to 3.
A horizontal line. So
Right. So yeah, I agree that this will be y is equal to 3.
yeah.
So now I need to figure out which side to shade. So if it is more than or equal to 3, more than 3, right? So
It'll have to go above 3.
exactly, because all the values above will be more than 3. Excellent. Check here, mashing up linear programming now. Thank you. Right, give me a second. Uh, right, so Aaron, you understood this perfectly, yes or no?
Yeah, so I get it.
Okay, next one. Y is less than or equal to x. Do we know what the graph of y is equal to x looks like?
Um, well, will it be by ones? Because one X and one Y is like usually understood.
Wait, huh? I'm not sure if you're talking about the same thing, but let me show you how we could figure that out, right?
Oh,
So I'm saying that the graph is y is equal to x, right?
yeah.
Now this means that at every single point in the line, the y value must be equal to the what value?
The X value.
Right. So would this be legal? Would this be one of the points?
Yeah.
Would this be one of the points?
Yeah.
How about this?
Yeah.
Still going all right.
Yeah.
I'm gonna take my ruler. I want to make sure it lines up, right? So 1, 1, 2, 2, 3, 3. See what I'm doing there?
Yeah.
And I did it such that, watch, for all the points, the y value and the x value is the same. What, read that point off,
Eight, eight,
right? This point
11, 11.
makes sense, right?
Yeah.
All right. So we need to shade where y is less than x. Do you think I'm going to shade over here? over here? Region 1 or region 2?
Region 2, sir.
Let me see. So the test start. I'm going to pick a point.
Um, 8, sir.
Now, 88 will be on the line itself. I need to pick up in the region itself.
Um,
So any you said this region, right? So any points in this region.
oh, 9, 4, sir.
So that point will be 9, 4. Yeah.
Yeah,
And our line is y is equal to x, yeah?
yeah,
So here, let's forget about the equal sign for a bit, right?
yeah.
Where's y?
Y is 4, sir.
Where's x?
9, sir.
Right. Is 4 is what the line?
4 is less than 9.
So y is less than x. Is that what we want?
Yeah, sir.
Yeah. So we're gonna shade the lower portion. So for sure, will you be leaving out this in the exam?
No, sir.
Right, you'll be getting the marks. For sure. Right, so can you see the region where both of them actually overlap or not?
Yeah,
That would be over here, yeah?
yeah, they do.
All right. Last one. X plus y is less than or equal to 12, right?
Mm-hmm.
So the easiest points to use is the x and y intercept, right? X and y.
Yeah.
So x plus y. Let's just look at x plus y is equal to 12 first, right? So at the
Mm-hmm.
x, what do we know?
Y is equal to 0.
Right. So for y, what would I put?
X is equal to 0. Also, sorry. Y will put 0.
So x is equal to
12.
right. So for the x-intercept, I'm going to pay it by 12, right? So I'm going to power point by 12. That confusing, eh?
No, sir.
Wait, yeah, I make a mistake. That's supposed to be by the x-axis, watch. Because it's the x one.
The x-intercept.
Yeah. Right? And for the other one, the y-intercept, what do we know?
X is equal to 0.
So anywhere I see hexagon, right?
0.
So that'll be 0 plus 12 is what's in? 0 plus y is equal to?
12.
So y will be equal to?
12.
Right. And as the y-intercept, so that going on y-axis.
The y-axis, sir.
Right. So we have 2 points that we can connect.
Yeah.
Tell me, does that confuse you when you cite this?
No, sir, I get it.
Okay, weird. No, no, no. Oh. We need to figure out what side we're going to shade, right? We said x plus y is less than 12. Now, I think you probably noticed that pattern by now, right? Like if it's less than, we'll probably shade over here. If it's more than, we'll probably shade above.
Mm-hmm.
But let's just verify that. So I'm saying we could possibly shade over here, yeah?
Yeah.
So for me to test that, we're going to pick a point. For a way to pick a point anywhere in our region.
I just shaded this, sir.
Yeah.
Um, for 7, sir.
So, and our equation for that green line is what? What's the equation for that green line?
What you said, sir?
And what's the equation for the green line? What did we come up with?
X plus Y is less than or equal to 12.
Right? So the equation itself is x plus y is equal to 12. That's the strict equation. So here one. And I want to figure out where it is less than it.
Yeah.
So let's see. So x plus y is equal to 12. I'll leave it on the equal for now.
Mm-hmm.
X is what?
4,
Y is?
7,
So bring back to 12. 4 plus 7 is?
11,
11 is what than 12?
less than 12.
Is that the correct representation?
Yes, sir.
Awesome. So, all right. Are you seeing a region where all of them are overlapping?
Yes, sir, I see it.
Let's change this color. No, I wasn't like a color. Let's change it to. I was looking for a okay color. Okay, yeah, you see that region where all of them overlapping on. It's so like, I feel like it's hard to see. Let me know if you see that region. So we know that the green one is over here.
Yeah,
We know that the purple one is over here.
yeah.
And this one is over here.
Mm-hmm.
So the region is over here.
Oh, yeah, I see it, sir. It's in the middle.
Yeah, right here.
Okay, yeah. Right, I see it, sir.
Right, so identify by shading the region where satisfied frequent inequalities. We just did that. We shaded it. Determine from your graph the minimum values of x and y which satisfy the conditions. So guys, anytime you see the word minimum and maximum being thrown around in linear programming, you're looking at the vertices. So like you're looking at the vertices. So, right. So what is it now? Okay, so that vertice there, this one over here. Stop setting. Okay, can you see that this is one of the vertices here? Like some over here,
Yeah, so I see it.
that one, then over here.
Yeah,
And this one over here.
yeah, I see it.
So wait to read off the points from here. So this one is one.
3, so
How about this one?
6, 6.
This one?
9, 3, so
All right, so we want to figure out um all right. We want to figure out the minimum values of x and y which satisfy the conditions. So what do you think is the minimum values of x and y that satisfy the conditions? 6, 6, 9, 3, or 3, 3?
3, 3, so
For sure. 3, 3. Right? Right? So you would say three pumpkins, right? And 3 melons. So I will send this linear programming worksheet, this document. It contains a bunch of linear programming questions that we've done over the years. Right. But that's it for linear programming as
okay.
well. So that's it for relations, right? That is it for relations, functions, and graphs. So we looked at functions, coordinate geometry, right? And linear programming. Nice. Right, so guys, take a 15 minutes break. And when we come back, we're gonna start with vectors. Guys, people are still awake. Let me just did you all change your mind? Or like is vectors high up on your priority list still?
Vectors are still up on mine, so
Yeah, it's early.
Okay, we'll say no more. Say no more. Right? Okay, when we come back, look at vectors. Good. What's this? We finish algebra, finish relations, functions, and graphs. We finish this. So in 15 minutes, I'll send out a message in the chat. You can stay in the meeting if you want. Right. Vectors. Okay, look, I already have it here. So guys, let's go. So when we know in vectors, you need to know directions. So generally speaking, this is the most common form of a vector. So the column vector form. Column vector form. Right? So let's just say I have a vector V, right? It will be given by X, Y. Now, X would refer to horizontal movement. So guys, when I say horizontal, what do I mean?
Across?
Right, so left or right, yeah? And Y would correspond to a vertical movement. When I say vertical movement, what do I mean?
Up or down?
Right. And the other form you need to be familiar with is this form over here, xi plus yg, where I would correspond to horizontal movements. Same story, I would correspond to horizontal movements, and g would correspond to vertical movements. Okay, these are the forms you need to be familiar with, right? You must know what a position vector is. Do any of you guys know what a position vector is?
No,
no,
sir.
so
All right, so a position vector is a vector that starts from the origin, right? So check this out, right? Okay, get a graph here. All right, so let me get an example. Let's just say we had a vector O to P, right? O to P. And I said the vector O to P was 5, 7. So Aaron, let's try to understand what that means. So do you understand that this is the origin here? This is the origin. Yes or no?
Yeah, sir.
Right. So anytime we're dealing with a position vector, it means that we're starting from the origin and we're going to that point. So over here, it would seem that we're going from where to where?
5 to 7, sir.
Now,
Oh, sorry. O to P, O to P.
right. And to go from O to P, we have to take 5. We have to move 5 to the right and then 7 up. Remember, guys, remember, the first value here corresponds to a what movement?
A horizontal movement,
And the second one corresponds to it?
vertical movement.
Right. So if that's the case, if it's positive, right? If it's positive and it's a horizontal movement, do you think that's to the right or to the left?
It's to the right, sir.
Right. So we're going to start from O, and I'm going to move 5 spaces to my right. And what do you think I'm going to do next, guys? If it's 5 and then 7, that's 7
We're
we're
gonna go
to
up, sir. Up.
right. Okay, so if I say that this is point P, would that confuse you?
No, sir. I see. Understand.
So in other words, this is how I would go from O to P. And I'll put an arrow to show that I'm going from O to P.
Okay.
So this would be 5, and this would be 7. Is anybody confused by that?
No,
No,
sir. I
sir.
get it.
All right, let's just say we had O to Q. Actually, let me put on a point, and I want you to tell me what the vector is. So let's just say I put a point over here, right? And let's just say I call this Q, right? Guys, how would I go from O to Q? Whatever you tell me, you need to tell me the horizontal first, then the vertical.
You'd have to go to left, sir.
How much space is to the left?
3 spaces,
Yeah, 3 spaces to the left, and how much?
and then 4 spaces down.
Does everybody understand this?
Yes, sir.
So if I want to go from O to Q, like Aaron said, I have to move 3 spaces to my left and then 4 spaces down. Now, since it's 3 spaces to the left, it's going to be positive 3 or negative 3.
-3, sir.
So O to Q would be negative 3, right? And negative 4, and 4 down. Does that confuse any of you guys?
No, sir.
No, sir.
So if you know. Nope. Okay, cool. So you need to be familiar with the triangular rule, triangular law of vectors, right? So triangular of vectors. So guys, let me explain something. Anybody here from South?
No, sir.
Nah. Okay, well, let me explain our scenario here, right? Let's just say that you are from Davie, which I happen to be, right? I'm from Davie, and I want to go to Port of Spain, right? Do you guys think there's a maxi or something that I could take to go from straight Davie to Port of Spain?
No, sir.
No. So what I would have to do is I would have to go from DB to San Fernando, and then from San Fernando to
Port of Spain?
right. So guys, can we all say that for Rajiv to go to go to Port of Spain, I would have to go from DB to Sando, and then from Sando to Port of Spain. Does that make sense?
Yes,
Yes,
sir.
sir.
Right. So if I want to go from DB to Port of Spain, I would have to go from DB to Sando, and then from Sando to Port of Spain. It's the exact same concept in vectors. Let me give you an example. Let's just call this point R and call this point Q, right? And when we do in vectors, we typically treat the origin as the middleman. So guys, if I wanted to go from R to Q, how could I go from R to Q? How would I go from R to Q? I feel that.
Well, you could just go up, sir.
Right.
Go,
So, Iran, if I want to go from R to Q, I'm starting my journey from where?
at the point of R.
Right? So I want to go from R to Q. So if I want to go from R to Q, I can go from R to O and then from O to,
Q.
right? So R to Q would be equal to, you tell me, is exactly what I just told you.
R to O. And then O to Q.
You understand that?
Okay. Yes, sir. But
What?
so you can't, you can't, this diagram, you can't, it looking like you could just go from R to Q just up by itself.
I hear what you're saying, right? Like you're saying I could just go straight from R to Q. But when we are dealing with vectors, we talk about, okay, how could I go from one point to another point using a horizontal component and a vertical component?
Also, so in a way that isn't just straightforward.
Yeah, so you're not going straight from R to Q. You're looking at the equivalent, route you could take to end up from R to Q. So not just R to Q. How can you go from R to Q? Well, I could go from R to O and O to Q. The same way like this example over here. If I want to go from David to Port of Spain, right? David to Sando and Sando to Port of Spain.
Yeah, I get it. I get it also.
I could say that with yeah, input that host. So let me imagine a scenario, right? You are a tornado. But in well, we just go to the so I'm not being right. I like so that I could just fly straight to tornado, right? And I put first from your house to the port, and then port again. So in a legal, we just fly straight to tornado.
Yeah, it's not legal.
So I have check one point, you have like go from one point to the next point in ways that legal, ways that you could, ways that make sense. Because what you say, "Aye, to go to the bagel, we need to just take it in the backyard and just fly out."
You can't do that, you get shut down like a bird,
You can't do that.
right?
You have to go to the port first and then to do
Right?
similar scenario.
Right? So you can't just go from R to Q. Right? When we're dealing with vectors, we are breaking up our movements into a horizontal movement and then a vertical movement.
Okay,
So
sir.
R to Q, I'll go from R to O and O to Q. Now, guys, it's also important that, when we're dealing with vectors, direction is important, right? In vectors, direction is important. So let me explain what I'm talking about. If I say that O to R, let's just say that I say O to R, right? is let me just say U, right? What do you think I have to say R to O is? Do you think I'm going to call it U as well? Tell me, Aaron.
No, sir, you wouldn't call it U, sir,
Call it negative U,
because
right?
you're going in the opposite direction.
Right. So in vectors, anytime you change direction, you change the sign, right? So you change direction, you change the sign. Change direction, change the sign. Change direction, change the sign. So do we understand these concepts? So find vectors, like, do we understand the general way in which it's given to us as a column vector? Do we understand what a position vector is? Do we understand the triangular law of vectors and how direction is important? Tell me.
Yes, sir.
Guys, you guys in the Zoom, I wonder if you understand these concepts so far.
Yes, sir.
Yes,
Just
Yes,
sir.
all right, so all right. So let me give you a example, right? Check this out. Let's just say I have this point over here, call this P, right? And let's just say I have a point over here. Call this point Q. Did somebody tell me what vectors O to P and O to Q would be? How would I go from O to P, Aaron?
It would be 0, 5.
Nah. So, Aaron, if I want to go from O to P, again, I'm starting from my origin. If you see O, it's a position vector. So I'm starting from my origin, and then you're going to move horizontally.
Oh,
So how can I move horizontally to be in line with P? I have to move how much spaces horizontally to be in line with P.
5 spaces, sir.
Yeah, and then I would have to move how much spaces up to reach P?
6 spaces.
Yeah, one space.
I thought you said Q, sorry.
Oh, nah. So that would just be, so the vector for that, that would just be 5 or 1. Let me know if you understand that.
Okay. So yeah, so because it's not exactly on the line, you'd have to go up to fully reach P.
Exactly. So you're splitting it up into a horizontal component and a vertical component. So to reach P, I move 5 spaces to my right, right? And then I move 1 space up to reach P,
Yeah, okay.
right? Okay, tell me O to Q now. How would I go from O to Q?
You go 6 spaces up.
Okay, wait, whoa, take your time, right? So remember, when you write a vector, it's always the horizontal part first and then the vertical part. So remember, a vector is written in the form X, Y,
Okay. Yeah,
or
okay.
horizontal, then the vertical. So move horizontally first.
Um, Move 1 space horizontally.
In which direction? Left or right?
Right.
And then how much space is up?
6 spaces up.
Right, so what my vector be?
1, 6.
Yep, 1, 6. Does everybody understand that? Yes or no?
yes, sir.
Yes, sir.
Okay, cool. So, so far, like I said, guys, it's just directions, right? It's just directions. So, Aaron, I'm gonna throw in a twist into this, right, Aaron?
Okay.
What if I asked you to tell me how to go from, what if I wanted to go from Q to say P? Now, let's think, how could we do that? So if I wanted to go from Q to P, if I wanted to go from Q to P, right? Where am I starting from?
The Q point, the pointer Q, sir, Q.
Right? And how would I move next if I want to end up at P?
You'd have to go down to O,
right? And then from O to
P.
right. That makes sense, right?
Yeah.
So I'll write that as Q to O plus,
O to P.
yep. Now let me explain something, right? We have we have vector O to Q. So if I want to go from O to Q, what vector would I take?
1, 6.
But if I want to go from Q to O, can we see that that's in the opposite direction?
Yeah. So it'll be negative 1, 6.
-1, -6. Because watch, if I wanted to go from Q to O, I would have to move one space to my left, and then how much space is down?
6 spaces down.
Right. So in other words, QO is the same thing as negative OQ. That confused you? You understand that?
No, I get it. I get it.
So it's just the same thing as OQ, but since it's the opposite direction, I change the sign. Right? And well, I didn't change the sign for OP because can we see what they're going in the same directions?
Yeah, they are.
Right? So I will write minus open bracket 1, 6. Or if you want, you can just change the signs one time, which is what I feel would be easier, right? So negative OQ would just be -1, -6. Some of you understand that.
Yeah, I get it.
And OP would be,
Will be 5, 1.
so it's -1 plus 5.
4, so
-6 plus 1.
negative 5, so
Okay, you ready for me to blow your mind?
yeah.
All right, watch this, right? So according to these instructions here, this tells me how to go from what point to what point.
From Q to P, so
Okay, watch this, right? Watch this. And according to the vector we came up with, if I want to go from Q to P, how do I have to move?
you'll have to go 4 spaces to the right,
And then
5 spaces down.
let me see if that real, right? Let me see if that real. So I'm gonna start my journey from where here?
The Q, sir.
Right. So check this out, right? Check this out. So it's telling me, right? From Q, I
Mhm.
should go 4 spaces to my right, yeah?
Yeah,
So right now we at 1, you see in that?
yeah.
If I move 4 spaces, I'll end up at,
At 5, sir.
okay. And then it's telling me to move how much spaces down?
5 spaces down, sir.
And we had 6. Wait, 6 minus 5.
1, sir.
Bam. Understand?
Yeah.
Yeah. So that's vector sphere. That's the basic concept of a vector. Just directions.
It seems so easy.
I know, right? Like vectors, I'm telling you, like vectors is one of the least math heavy topics, at least at this level. It's just highly like conceptual. It's just like directions. All right, so take a screenshot of this, guys. Wait, I'm gonna just add in something. Yeah, so take a screenshot of this, guys. Yeah, guys. I have a screenshot.
Yeah, sir.
Yeah.
Okay. So one of the other things you need to be able to do is you need to be able to find the magnitude of a vector. So how do you find the magnitude of a vector? The magnitude is just the length, right? So Aaron, if I asked you to find the magnitude of QP, right? What you would be finding for is this length over here, right? If I asked you to find the magnitude of OQ, you'd be finding the length over there. And to do this, you just use Pythagoras theorem. You're probably wondering, well, what? How? What is right? What kind of triangle is that?
A right angle triangle, sir.
Yeah. And the distance from here to here, right? 1 to 5 is 4. And the distance from here to here, 6 to 1 is 5. And I can use Pythagoras theorem to figure out this length.
Yeah.
Yeah, so that's literally what the magnitude of a vector is, right? So magnitude of a vector, right? If to find the magnitude of a vector, it's given by the symbol, which kind of looks like the determinant. So the magnitude of a vector v is just equal to the square root of x squared plus y squared. So whatever the horizontal part is, you're going to square it and add it to the vertical part squared, and it's finding the square root. Aaron, isn't this exactly Pythagoras theorem?
Yeah.
Yeah, it literally is Pythagoras theorem. Right, so that's how you find the magnitude of a vector. Let me give you an example. Find the magnitude right, so let's find the magnitude of vector 4 minus 5. So guys, this is in what form? That is in what form? In what vector form? Do you remember? Check back. It's in what vector form?
A column vector.
As any column vector form, right? So if it's any column vector form, right? What is x and what is y?
4 is x and -5 is y.
So the magnitude of QP will just be equal to the square root of whatever x is. So x is 4, so 4 squared, right? Plus, open bracket, y is -5, so -5 squared. Okay with that?
Yeah, so
Right? And that would be 16 plus 25. What's 16 plus 25? 41.
41, so
Right, so tell me your answer to two decimal places.
6.4, so
6.4, exactly right. Two decimal places, right?
yeah.
You're 6.4. That's a little sus. Right, so 6.40. Yeah. If they ask you the two decimal places, you have to put in the extra zero, right?
Oh, I know usually that zero, they do usually put zero, so I thought 6.4 would work.
That's fine. If you put 6.4 is correct. But what I'm saying is if you ask it wrong, for two decimal places, you need to show two decimal places.
Okay.
Yeah. So that's how you find magnitude of a vector. Right. So the next thing you need to be able to do is find a unit vector, right? A unit vector. Wait, so is there anybody that didn't understand how I found the magnitude of vector QP? You just had to use this formula. And V is just a vector, right? V could be any vector. So to find the magnitude of a vector, it's just the square root of its x value squared plus y value squared. That's it. All right. Let's move on to unit vector now. So unit vector. So guys, whenever you hear a unit, what length do you think of a unit? A unit, what length do you think of?
Um,
If I say,
one,
right? So a unit means length of one. Length of one. So if you want to find a unit vector, right? The unit vector is given by this formula. So it's going to be v top hat, right? And it's going to be the vector divided by the magnitude of the vector. So if you don't believe me, I can show you what I mean. Let's just say we're dealing with that same vector QP, right? Let's just say we wanted to find the unit vector for QP. that would be equal to vector QP, right? Now, when you deal with the unit vector form, you're not going to write it in the column vector form. You're going to write it in the form xi plus yg. That's how you typically write it in the unit vector form.
Okay.
Let's just recall what QP was. QP was 4 minus 5. Now, if I'm writing that in the unit vector form, that would be equal to 4i minus what? Take a guess. 4i minus?
Negative 5g.
It's just 4i minus 5g. So check this out. I promise it's real easy.
So what? So just before I continue, what form you said is this again? XY plus YJ was the name of it?
This is the unit vector form.
Okay.
Right. Right. And we found the magnitude of QP to be what?
6.40.
Right? Now, in regular maths, you're going to get, they're not going to be this wicked, right? You're going to get fractions and whatnot. But for the sake of completeness, I'm going to leave it as root 41. Right? Just to show you something. So like in the previous part, we found the magnitude of QP and we got it to be square root of 41. So then the unit vector would be, so here, now we're going to split this up, right?
Yeah.
So guys, I have a question, right? If I had, say, 4 over 5 plus 2 over 5, essentially the denominators are the same. And I could add those together.
Yeah.
So wouldn't I say 4 plus 2 over 5?
Yeah.
So here we're going to do, right? Actually going to split this up following the same concept. But remember this. So I could actually write that as 4 all over square root of 41. I minus what? You take a guess. Minus?
5 over the square root of 41.
Yep.
G.
And that's just like that, you'll find a unit vector. Now, earlier today, right? So just a little while ago, Aaron, didn't I say a unit vector has a length of 1?
What you said, sir?
I said a unit vector has a length of 1.
Yeah.
Check this, right? If I find the magnitude of this, what do you think I'm supposed to get? So the magnitude is the same thing as the length or size.
1, sir?
Yeah, supposed to get 1. Check this, right? Check this. So to find the magnitude, it would be the square root of the x values. This is the x value. So 4 all over root 41 squared, right? Plus the y value, right? Which in this case is negative 5 all over square root of 41 squared. So plug that into your calculator and let me know what you get. I'll plug it in as well. So the square root of open bracket 4 all over square root of 41 squared plus open bracket fraction minus 5 square root of 41 close brackets squared. Aaron, when I press equal, what am I supposed to get?
Just now, sir, still typing.
All right. I said, Aaron, you got to happen, right?
Huh?
You got to happen, right?
Yeah, okay. Just now, sir.
That's good. Right, then. This is going to be a nightmare to type into a shop. So Casio users, if you have any other Casio users, let me know if you all got through.
1, sir.
Yeah. And that's because a unit vector has a length of,
1.
yeah, mind blowing, right? Telling you, everything will make sense. So yeah, so far, we went through the basic concept of a vector and its most common form, column vector form, right? That's what we went through so far, column vector form. We looked at a position vector. I showed you the triangular law of vectors, right? I showed you what happens when it changes direction, the sign changes. I showed you how to apply the triangular law of vectors as well as the change in direction over here. I showed you how to find the length or magnitude of a vector. I showed you how to find a unit vector. The next thing I need to show you is how to figure out the direction of a vector, which is just the angle. Let me just show you. Let me just show you in the diagram. So Aaron and the rest of you guys, the direction of this vector, right, would just be the angle between it and the x-axis as well.
Okay.
The direction of this vector would just be the angle between it and the x-axis, right?
Yes, sir.
So to find the direction of a vector, we typically find directions of position vectors because they start from the origin. So to find the direction of a vector, now by the way, everything I'm writing here is on the syllabus. It's just that they like some things more than other things. So we went through the concept of a vector, magnitude, the unit vector. I'm gonna go through direction now, right? Then I'm gonna go through this. This is very easy. We went through triangular law, parallelogram law. You don't need to know that. You'll see why I'm saying that when we do the questions. Right? Displacement and position vectors. A displacement vector is just a vector that does not start from the origin, right? That's all a
Oh,
displacement vector is. It just does not start from the origin. But all of these things you could actually figure out. It don't make no sense in like practical learning. Again, you'll see what I mean when we start the past paper questions. So if you want to find the direction of a vector, is an angle, right? The direction of a vector is just the angle between, it's just the angle between the vector, right, and the x-axis. And to figure out the angle, theta, it's going to be tan inverse, right? Right? The magnitude or the absolute value of y all over the absolute value of x. I'll explain what I mean shortly. So let's just say I wanted to figure out the let's just say I wanted to figure out the angle, right? So find the direction. So find the direction of vector QP. Find the direction of QP. Actually, I should use OQ. I'll use OQ because there's negatives here. All right. All right, so Aaron, we want to find the direction of OQ, right? So let me show you how we're going to do this. So you see how the x value and the y value are both negatives?
yeah.
Can you see how I wrote these two lines on either side?
Yeah.
It means that if I want to find the angle, what I'm actually going to do, right? I'm actually going to find tan inverse of the positive value of y all over the positive value of x. So y is -4. So I'm not going to use -4, I'm going to use 4. Right?
So you just change them from negative to positive.
Yeah. So we strictly use positive values. If it's a negative value, use the positive value, right? Right?
Okay.
And x is -3, so we're just going to use 3. So find tan inverse of 4/3 from now.
Um, 53.13, sir.
53.13?
Yeah,
Right, let's see if that makes sense, right? Let's see if that makes sense. So this is O to Q, right? Yeah, this is.
yeah.
So I said that the angle would be over here, right?
Mm-hmm.
Let's see. We're going to be like 53 point something else.
I said 53.13, sir.
Say no more. 53.13. Let's see how true that is. Now we tried kind of approximate here, right? So like it's not gonna be like exact, right? But watch. This is 0, right? This is 50, 53. See that?
Yeah.
It's crazy. Everything works, right? Yeah. And again, that is just figure ratios, right? Because if you know this is 3, this is hypotenuse, this is adjacent, this is opposite, right? You have O and A. Say use tan theta is equal to O over A, 4 over 3. Theta is just tan inverse 4 over.
Oh,
All of this is just stuff you did before, right? All of this is stuff you did before. So to find the direction of a vector is just tan inverse, right? Of the magnitude of y over the magnitude of x. And that will tell you the direction of the vector. Let me know if you understand that.
yeah, I get it, sir.
Okay, what about the rest of you guys in class? Are they real quiet? And I feel like are they real confused? Like
Not
real.
true. No, no. That's true.
Okay. So the next thing I want to look at is parallel and collinear vectors. Parallel and collinear vectors. So you can show that two vectors are parallel or collinear if you could write them as scalar multiples of each other, right? If you can write the vectors so what do I mean? Give you an example, right? Let's just say we had a vector O to A, right? And we said O to A was it's okay. O to A was say 3, 3, 4. And I told you that we had another vector O to B, right? And vector O to B was 6, 8, right? Are you seeing anything in common between OA and OB? Anything at all?
They're both positive values, sir.
Nah. There are positive values, but let's not go and get to that. Do you know what scalar multiple means?
No, sir.
All right. Check this, right? If I scale up something, doesn't that mean I just make it bigger? If I scale up something.
Yeah.
Okay, so check this, right?
Oh, wait, I see it. The OA and OA scaled up by 2, sir, to get to OB.
Yes, yes, man. Yes, yes. So you see, we could actually write OB, right, as 2 times OA. So you see how we can write them as a scalar multiple of each other?
Yes, sir.
So that means a parallel. And I'll show you what it means graphically, right? Because maybe you might have trust issues. The rest of you guys, maybe they might have trust issues and they want to see it for themselves. I'll show you. So as you can see, my Apple Pencil dead. But in charge, it's on a break. Yeah, boy. Um, I don't think they can. Oh. Yeah. All right. Yeah. So guys, my pencil is charging, right? But guys, I have a question. OB is 6, 8, right? And OA,
Yes, sir.
if I multiply everything in OA by 2, what would I get?
6, 8.
OB, sir.
Exactly, I'd get 6, 8, which is OB. So can we see that it would take two OAs to make up OB?
Yes, sir.
So I would say that they are collinear and parallel. Parallel just means that the vectors pointing in the same direction, and collinear means they're in the same line. Yeah. So we can move on to past paper questions now. That was essentially it for vectors.
Okay, sir.
When we do in past papers, I'm telling you, it's just going to be a bunch of directions. It's literally the whole concept of it is literally just directions, right? It's literally just directions. How would you go from one point to another point? As well as the stuff we'll look at just now. Right? All right. So what is percentage reach? Yeah. So for those of you who are not seeing it, right? Check this. We know that OB is 6, 8, right?
Yes, sir.
And OA is 3, 4.
Yeah.
So 2 by 3 is 6 and 2 by 4 is 8. So we can say
Yeah.
they are equivalent. So I'm going to draw it graphically and you'll see it and it'll make so much sense. So the first one is 3, 4, right?
Mm-hmm.
So I'm going to move 3 spaces to my right and then
Right. And 4 spaces to the top, sir.
right. And that first vector there is OA. Come on, no open it up. Actually, I think you do good. Yeah. All right. All right. So OA. All right. Cool. Did anybody get confused by that? It's 3, 4.
Sir.
3 to the right, then 4 up. Right? Okay. Now let's check OB. And you're gonna see everything making so much sense. Right? So OB is 6, 8. So guys, how would I go from O to B then?
There will
6 to the
be
right.
6 spaces to your right,
And then
8 spaces to your top.
right, exactly. So let's see where we're gonna end up. Wait, sir. So guys, watch this. Prepare to be mind blown. Wouldn't this be O to B?
Yeah, sir.
Yeah.
Yeah. Yeah, it is. So like, watch this, right? Can we see that both of them point in the exact same direction?
Yeah, sir.
I see now, right? One point in here and the other one point in here. Like, can we both agree? Everybody, can we all agree that it pointed in the exact same direction?
Yeah,
Yes,
sir.
sir.
The only difference is OB is 2 times the length of OA. Yeah,
Yeah, sir.
as well. So can we all agree that if two vectors are pointing in the same direction, they're parallel?
Yes.
Yes, sir.
Parallel means same direction. And collinear means that they're on the same line. You can see that there as well. So if you want to prove that vectors are parallel or collinear, you need to write them as scalar multiples of each other. That's what we need to be able to do. Right? And guys, can we see that, if you wanted to go from O to B, you would have take it 2 ways. Let me know if you're seeing that.
Yeah.
No, there I see it, sir.
Awesome. So I ready to start past paper questions now.
Yeah.
Yeah.
Good. Right? All right. So, give me a year.
This year, sir.
Say no more. 2025 June. Okay, 2025 me. So I promise all is just like heavy directions, eh? It's like heavy directions. It's hardly any calculations. You just like get a look at it and see how to go from where to where. So Aaron, let me start this question off, right?
Okay.
So you did this here.
No, no, sir. I forgot. I said I did June. I did 2024, sir.
Oh, 2024. Oh,
Mm-hmm.
okay. All right. All right. So get this I read for now.
In the diagram below, OPQL is a parallelogram. OP is equal to R and OL is equal to S. T is the point such as PQ is equal to QT. The point M divides PL in the ratio 2 to 1.
Right. Let me try to understand what the heck they're talking about, right? Also big up to boy. Man mash up electronics, boy. Yeah, boy. Anyway, right? So yeah, finals out now. It's finals, like we're going to see what we do. Yeah. All right. So Aaron, they say
Yeah,
O to P, we call an O to P what?
R,
And O to L is,
S,
and they're saying that T is the point such that PQ is equal to,
QT.
right? So can we see that PQ and QT is the same?
Yeah.
Okay, would, right? And the same point M, so point M is over here, divide
Mm-hmm.
L in the ratio 2 to 1. So can you see that if this is ML, right? If this is ML,
Yeah.
then it would take 2 MLs
Uh-huh.
to make up M to P.
Yeah.
You can see that, right? That makes sense.
Yeah, I could see.
That is why they're saying 2 to 1 ratio.
Yeah.
Take 2 of them here and 1 here to make up P to L.
Yeah, I can see it.
Okay, would. So P to L now. P to L. So how would I go from P to L? So P to L. So I tell you
Uh,
heavy
you,
directions, right? Tell me the directions.
um, you could go from P to O
Right? I can go from P to O. Uh-huh.
and then O to L.
Guys, does that make sense? If I want to go from P to L, I can see how that making sense.
Yeah.
So,
Now, my question is, guys, remember in vectors, if you go in any opposite direction, you change the sign,
Yeah,
right?
a negative.
So, guys, yeah. So if O to P is positive R, then P to O is
Negative R.
yes. Are we going in the same direction as O to L here?
Yeah.
So that'll just be yes. Right? So P to L is just what?
Negative R plus S.
Aaron, that was easy, right?
Yeah.
Like, you see, like, it's not much heavy. It's more like, okay, how would you go from one point to another point?
It was common sense heavy.
Yeah, I would say I just use that term, I just use that term very carefully, yeah? Because, like, I could pull up why I think it's common sense and when you think it's common sense and it'll be different. I think common sense is highly subjective. Like, just imagine common sense for Einstein or like common sense for Isaac Newton, you know?
Yeah.
So like I just use it real carefully. Common
Yeah, I
sense,
agree with that too.
common sense is not the same for everybody. And people in Caribbean, they like to slander that, like they like to, bring up that talk about common sense. So dumb, right? All right, so O to M. All right, so guys, O to M. If I want to go from O to M, you know what I'm gonna do? I'm gonna connect O to M. That confuse you?
Yeah, sir.
I confuse you.
Yeah.
All right. Let me see how I can step back to not confuse you. Let me just take a screenshot of this. I don't want to confuse you. All right, so Aaron, I want to go from O to M, right? So
Yeah.
effectively, I'm starting from O and I'm going to
You're going to L and then L to M.
exactly. And if I wanted to look at that as a path, wouldn't that be O to M? Like this, O to M.
Yeah.
And now to actually go from O to M, like you said, it was O to L and then L to
M.
yeah. So you're not confused as it stands right now. You're not confused, right?
Yeah. Initially, so I was confused. I thought you went straight from O to M, like you didn't go the path. I thought that's what you was doing.
I setting it up like that. So maybe the next question they might ask us something about O to M and O to T. Maybe they might ask us if it's collinear. So that's why I just setting that up now.
Okay.
So yeah. Okay, so we're going from O to if I want to go from O to M, it's O to L, right?
Yeah.
Plus L to M, yeah?
Yeah.
Now when the past question, we found out P to L is minus R plus S, and
Yeah.
you keep that in mind, right? P to L is equal to minus R plus S. This is what might lose you. So be very careful with this. Do we understand that P to L, this entire thing is minus R plus S?
Yeah.
Okay, waiter. Okay, so this is S, right? This is S. And let me ask that question. Did P to L could be divided into how much mLs?
2 ml. So.
Nah, three, watch.
Oh.
ml, ml here,
Oh.
three. So let me ask you a question, right? M to L is what fraction of P to L?
Um. 1 PL. So.
What, a third of PL.
Yeah.
So you see this ratio over here?
Mm-hmm. Yeah.
That means we
That's
can
it.
split it up into three parts, right? Three parts.
Mm-hmm.
And this will be two terms. That confusing, you understand that?
No, I see it. I see it.
Word. So this is going to be a third. Now we want to go in this direction, yeah? L to
Yeah.
M, right?
Yeah.
This is where things might get a little complicated. So that would be a third of LP. Look at why I say that, eh? You'll be going in the same direction as what?
As
L to P, right?
yeah.
Now, so we understand that part of our answer, right? Part of our answer is S, right? And it's going to be plus a third of L to P. Now, in the previous part, we actually found PL.
Mm-hmm. Yeah.
What do you think LP would be if you had to say?
So it'll be the opposite. So
Opposite direction, so change the sign. Tell me.
it'll be R minus S.
Yeah, R minus S. Was it that confusing or like you understand where I'm coming from?
No, I'm understanding it now.
So L to P would be R minus S. So it would be S plus a third R, right? I'm going to multiply a third by everything there. So minus a third S.
Mm-hmm.
So S minus a third S. So you're not seeing it, but this is one, right? What's one
Yeah,
minus a third?
I see it. I understand. Yeah, it's understood.
And what is one minus a third? So I have one S over here, and I have minus a third S over here. So one minus a third is
2/3
So that'll be 2/3 what?
S,
Plus?
1/3 R.
Okay. What do you think about it? Like insanely difficult or like you feel like it's manageable?
Yeah. Once I was able to get a good grasp of it become manageable.
That's good. But let me explain something, right? That's not the only way you can answer the question, you know?
Have another way?
Yeah. So guys, this is what Aaron suggested, right? He said that, if you wanted to go from O to M, you could go from O to L and L to M. Are you all seeing any other paths you could take if you want to go from O to M?
Yeah, O to P and P to M.
Yeah. And that would be a little easier, eh? Because you wouldn't have to find LP if you do that. Because it will be in the same direction, right? So O to P, right? And P to M. Now I have a question, right? So we're going in the same direction here. R, this is R, right? But I have a question. So then now, you was talking, right?
Yes, sir.
So then now, we said that this PL is actually broken up into how much parts?
3 parts.
Right. And this would be how much out of the 3 parts?
2/3.
Exactly. And 2/3 of the entire thing, which is PL.
Yes, sir.
So this would be 2/3 of P to L. So if I want to go from O to M is just going to be O to P, O to P plus P to M. Right? O to P is R. We're going in the same direction. So R, right? And P to M, that is 2/3 PL. Then now, didn't we find
Yes, sir.
the last part?
Yes, sir.
Right, we did. That was minus R plus S, I think.
Yes, sir.
Yeah. Aaron, like, are you being mind blown by how much sense this thing can make?
Yeah.
It's like crazy, right? And so then now we have 2/3 by minus R. That would work out to be what?
Minus 2/3 R.
Then now, I'm gonna if you understand that.
Yes, sir, because I'm multiplying 2/3 by any brackets.
Exactly, and I have minus 1. So 2/3 by minus 1 is minus 2/3. And over here it's gonna be 2 over 3S. So you're not seeing it, right? But what number is understood to be in front of the R? Tell me that now.
1, sir.
Yeah. So if you're confused by this, you can plug it into a calculator, right? So you could say 1 minus 2/3. What is 1 minus 2/3?
1/3.
So now make sure you're getting that third, right? So 1 minus 2/3 is a third. So that'll be a third R plus 2/3 S. So then now make sure you get any third, right? So you'll have to put 1 minus open bracket 2 divided by 3 close bracket. I think you might just see 0.33333,
Yeah.
which is a third, right? Did you know that?
Yeah. Yes, sir.
So now this is another way you could do it. I feel like you gotta do it like this. And honestly, I wanna do it like this myself.
Yes, sir.
But Max, that question, right, Aaron? Are the answers different?
Yeah. No, sir.
No,
They are
it's the exact same, right? It's just
they just switch the positions.
that's all. That's all, but they are equivalent. It's a big O. Big O. Right. Watch. You see, look at call it. They want me to prove that OM and T are collinear. So watch this, right?
Yeah.
If I want to prove that some lines are collinear, I need to prove that they're on the same line. So they want me to prove that OM, and T are collinear. That's what they want me to prove.
Yeah.
So let me show you how easy this is going to be, right? Easy maths. So I would actually, to understand this, I would actually connect OM and T.
Okay.
Does it look like they're all on the same line, OM and T?
Yeah.
Yeah.
Yeah, let's see now, right? Like this O, this M, and this T, all on the same line. That makes
Yeah.
sense.
Yes, sir.
If I want to prove that they are collinear, I need to be able to write two of them as a scalar multiple of each other or something. Just by looking at this. And you can see that O to T is the entire thing, like the big vector.
Yeah.
Yes, sir.
You can see that, right? So maybe I should find what O to T is. Maybe I should do that. So if this is S, right? What do you think this could be?
Q.
S,
That would be S, right? And what do you think this could be? They told us that, this and this was the same.
S, it'd also be S.
So the entire thing would be
PT,
yeah, the entire thing would be.
eh,
So I think P to Q is S and Q to T is S. So how much S is you had to take to go from P to T?
2S.
That's all. Right? 2S. And you had to go from O to P end.
Yeah.
So O to T is just O to P plus P to T. So now let me know if you understand everything.
Yes, sir.
So O to P is R and P to T is what?
2S.
2S. Right. So if I could show, here what I'm saying, right, guys? Here what I'm saying. If I could show, right, that it would take some amount of OM to make OT, in doing that, I would prove that this and this are on the same line. Remind me, guys, if we find OM previously,
Yeah, so
what was OM?
that
What,
was two-thirds R plus one-third S, or two-thirds S plus one-third R, sorry.
2/3 S plus 1/3. So I'm just gonna rearrange this, right? I'm just gonna put the R first and the S second. That's not illegal, that's fine. So like a third R plus 2/3 S. Did I break anybody heads or like I don't understand what I'm doing?
No, so again.
I just didn't know. I confused you. You understand? I just
Yeah, that's such a wrong, sir.
that's fine. So we didn't break any laws on us.
No, because it's addition.
Exactly. So guys, logically, when you look at this, it looks like OM is what fraction of OT?
A third.
A third.
Well, let's see now, right? So if that is the case, how much OM do you think it would take to make OT?
3.
What do you think?
2, sir.
3.
Oh,
Check it again, right, Aaron? This is O1 OM. This will be another OM. And this will be another OM. Seeing that?
yeah.
So Aaron, again, it's collinear if I could show that OM is a scalar multiple of OT or vice versa. So we just predicted that it would take how much OMs to make OT?
3 OMs.
So if I could show that mathematically, we set. So I'm going to say, right? I'm going to say that O to T could be written as 3 what?
3 OM.
Right? And we need to prove that mathematically. So O to T is R plus 2S. And OM is a third R, right? Plus 2 over 3S. What's 3 by a third?
1, sir.
So that would just be 1R, which is R. What is 3 by 2/3?
2S.
Bam. Legendary. Let me know how easy that was.
That was easy. That was manageable, so.
Yeah. Vectors is pretty easy. If you understand it, right? It's just, like I said, it's just directions. Like, how could you go from one point to the other point? If you can understand that concept, you set for vectors. And that's 3, 4, 5, 5, 6, 6 marks. Okay. Right. So next question. I want to go to 12 o'clock, right? Call it a night. So
Okay.
Please try to be on time tomorrow, right? I'm gonna see how much work I could do. If we don't finish the syllabus, I will just continue going until we are finished with the syllabus. So maybe an extra day or something. Yeah. But again, I'm not rushing anything, trying to take my time. Right. Let's check out January 2025. January 2025. Let's check this out. Right. Adika, you wanna mash up this question with me?
I could try.
I don't like that mentality. Don't get me that I could try. Say me like I'll mash it up.
So it might mash me up.
Hey boy. No man. No, no, no. You're easy, yes. Hey, let me go, right? So, get the question I read for me.
Um, the diagram below shows quadrilateral OLMN in which O is the origin. OL is equal to 4y, OM is equal to 6z, and ON is equal to 2z. The point A lies on LM such that LA AM is equal to
1 to 2
1 to 2, and the point B on MN such that MB
to M to M to BN to BN.
to BN is equal to 2 to 1.
Right. You feeling cooked?
Um,
No, no, don't say no.
nah,
I
nah.
don't say yes. Confusing myself there. You're gonna be fine. You're gonna be fine. Right? Just wing it. So they say that LA to AM is 1 to 2. What do they mean by that? So Adika, when you look at this diagram, right? How much LAs does it look like it'll take to make LM?
I could,
It'll take 3, right? Take 3 LAs.
oh yeah.
So in other words, LA will be what ratio, like what fraction of LM?
LA will be a third of LM.
And AM will be what fraction?
2/3.
Yeah, 2/3 of LM. See, look how fast we understand that. We good. We good. It's fine. Right? Okay. How much BNs will it take to make up MN?
Um, hold on.
Approximately, like how much does it look like?
Like 2/3.
Like 3. It look like it'll take 3 BNs to make up MN, the entire thing.
Yeah.
This entire thing here. 1, 2, 3. See now?
Yeah.
So BN will be what fraction of MN?
It will be a third.
And BM will be what fraction of MN?
BM will be 2/3.
Exactly. Yeah. To express in its simplest form, M to N. M to N. Right? So I want to go from M to N. So M to N. How would I go from M to N?
Um, M to B to N or M to O to N.
Right. I prefer the second response, right? Because they wanted the answer into my X and Z. Right?
Oh,
So I would go from M to O and then,
N. O to N.
right. That makes sense?
Yeah.
I'll ask that question though. Right? So M to N, right? So m to n would be equal
to M to O
m to o, yeah? M to o plus
to O to N.
o to n. M to o. Mark's that question, right? What is o to m?
6e.
So what do you think m to o is?
6e.
Nah,
Negative 6e.
right, because you're going in the opposite direction, you see that?
Yeah. Oh,
What, so 1 to o to m going in this direction, so 6c. So we're going in the opposite direction, so minus 6c. Minus 1?
yeah.
Right. So it's going to be minus 6c. Right, and o to n now. O to n is what? Are we going
It
in
will
the
be
direction?
plus 2x.
Yes, plus 2x. You okay with that?
Yeah.
All right. What about the rest of you all? Easy one mark?
Yes, sir.
Okay, Aaron, easy one mark?
Yes, I think I would be able to get.
Okay, cool, cool. Right, find in terms of x and y in its simplest form an expression for L to N. So L to N. L to N. So later, let me just get a blank copy of this. Right, so we just found what M to N is, right? So I'll just put that in. Maybe you might have to use it in this question. What was M to N?
Um,
M to N
6e minus
or minus,
minus 6e plus 2x.
right? And we want to figure out L to N, right? L to N. So what would L to N be? So for you to visualize this, I'm going to connect L to N, right? So how could I go from L to N?
You could go L to O
L to O,
to N or L to M to N.
L to O, and O to N. Tell me if you see it now,
Yeah.
right? Now L to O, so let me just write that down, right? So it's another one mark question. If it's a one mark question, just know it's like there's nothing to it. It's just like s- straight from the diagram. So L to N would be equal to L to O plus O to N. L to O plus O to N. So I'm that question, right? L to O. Are we going in the same direction as O to L?
No, you're going to need opposites.
So that'll be minus 4y, yeah?
Yeah.
This will be 2y because going in the same direction. So it's going to be minus 4y, right? Plus 2.
Plus 2x.
Easy.
Yeah.
Nice. Now they want us to show that A to B is 2/3 of 2x minus 4y. So here what? Maybe we should write your answer as 2x minus 4y. If I write it as 2x minus 4y, would I confuse you?
No.
You understand? I just put the 2x here and the minus 4y here. That's all.
Yeah.
Okay, cool. So A to B now. I'm going to connect A to B.
Um,
All right. So this one a little tricky. It's a 2 mark question, but we'll figure it out when we have. Right. So, Atika, if I want to go from A to B, right?
Yeah.
How can I go from A to B?
A to M and M to B.
Right? A to M and M to B. Let's see if that's legal. Let's see, right? So do we know what A to M is? We know what, okay, do we know what L to M is? Let's see. So we know what M to N is. Wait a M to N to N. Okay. Okay, let me think. So A to M. They give us any other piece of information. So A-
To 2.
Say that again.
All I gave was 1 to 2.
Or they
It's
give like a ratio.
an easy question, right? I'm sure we can figure this out, right? What I would do is I'd find for L to M first. I'd find for L to M first, right? And then I'll find a fraction of L to M. And then we're ready to find for MB. To find for MB now, that'll just be a fraction of MN. Should be 2/3 of MN. All right, so that's the only thing I see that we could do. Seems like a lot for 2 marks, but that's the only thing I see. So guys, as it sounds right now, we don't know what L to M is at all. We do not have L to M. I need to figure out what L to M is. And why am I saying that? I'm saying that because what fraction of LM is this?
2/3.
Right, this is 2/3 of LM. So if I know what LM is, this shouldn't be a problem. And M to B is what fraction of MN?
2/3. 2.
Yeah. And if you realize we actually have MN, right? So that shouldn't be a problem. The problem is the fact that we don't have LM. So let's find for LM first. So guys, how would I go from L to M? How would I go from L to M?
L to O and O to M.
L
What are
to
you doing?
Yeah. So that would be so L to M, that would be equal to L to O, right? Then
To
O to M,
M and N to N.
yes. Now L to O is what? What is L to O?
4y
Minus.
minus 4.
4, right?
This is yeah, minus 4y, because O to L is 4y. We are going in the opposite direction, so minus 4y. What is O to N?
2x.
2x.
Plus 2x. I am N to M now. Guys, don't you already have Mn?
Yeah.
So what do you think NM would be?
Negative 2x plus 6c. So,
Right? So yeah, just 6c minus 2x.
oh,
Is that the correct thing, eh? I just gonna write it in this order. This is the easiest thing. Guys,
okay.
So,
yeah?
why we using minus instead of plus?
Okay, let me explain something, right? In vectors, anytime it changes in direction, it changes signs. So if mn is given by minus 6c plus 2x, then the opposite vector, which is n to m, would be opposite signs. So instead of
Okay.
minus 6c, you turn to 6c. Instead of plus 2x, you turn to minus 2x.
Okay.
This is in the opposite direction. And a quick example, right? Look at this quick example. What is O to L?
4y
What is L to O?
negative 4y.
Exactly. So if m to n is minus 6c plus 2x, then n to m, which is in the opposite direction, be 6c minus 2x.
Okay.
Right? So that's going to be plus 6z minus 2x. Right? Right. So guys, we need to simplify this. Are you all seeing any like terms?
X.
Yeah.
2x
2x.
minus 2x. So positive 2x minus 2x.
I'll just send the 0, right? Because 2x minus 2x is 0. So I'm going to end up with minus 4y plus 6c.
Plus 6c.
Okay. So we just found what LM was. So that's LM, right? That's LM.
Yeah.
So A to M. So back to where you want to figure out. A to M is 2/3 of it. So if I want to go from A to B, if I want to go from A to B, that's A to M. That's A to M plus.
MGB.
So A to M is just 2/3 of what we just found. Try looking for a 2-mark question, boy. But I'm sure there's an easier way to do it. I'm just not seeing it right now.
Yeah. I
Yeah.
like to know we suffering.
Yeah, like this is outrageous. Right?
So one thing I learned about CSEC is that they will put the question they are the most working for with the lowest type of marks. So
They rarely do that in
All
2025.
all the time. All the time.
They rarely do that in 2025, boy. I noticed that. And January was hard compared to June.
yeah,
So A to M is just 2/3 of LM, right? And MB is just 2/3 of MM, right? So if you see, right, you probably factor out the 2/3, or we can do that eventually. Actually, we should do that one time. I'm gonna factor out the 2/3. If I do that, I'm going to write LM on the inside. So guys, what is LM? What is vector L to M?
4 negative 4y plus 6c.
Right? And what is M to N?
Negative 6c plus 2y.
Negative 6c plus 2x.
Oh, sorry, 2x.
Right? So yeah, you get the answer. That's how I working. Not easy. Right? So if you notice 6c and minus 6c, they cancel off, yeah?
Yeah,
And
leaving minus 4y plus 2x.
which could work out to be 2/3, right? Open bracket, 2x minus 4y. And that's it. Wow, that was a lot of work. If I wasn't on issues, I'd probably just leave it out. Like I'm being real, like if I was on age and I was doing this and I was running low on time, I probably would have just leave this out. Because there's so much work for 2 months, so much working for 2 months is crazy. So like honestly, right? I don't like when I say something easy, I really mean that easy. If something a little tricky, I will admit it, right? I will. This was like a multi-step question. You really have to think for it. But I'm sure there's an easier way that I'm just not seeing at all.
Mm-mm.
All right, let me continue. There's the answer. Crazy amount of work for a 2 mark question. Hmm. Yeah, it bugging now. I will keep on. Like, look how much work in this part two more question. But
And I leave that.
Yeah.
I will go through it. I'll see if I can find an easier way to do it. But the easier way, not looking very easy to find.
No, and next time we make mistakes and mess up the sound and after spending more time.
We get through, but we got the correct answer. It's just like looking for is crazy, right?
Yeah.
Right.
I'm think as long as we have the directions though and try to remember the steps, it's straightforward from there.
Yeah. It's just that you can't don't mess up your fractions on it.
Mm-mm.
Right. Part three. Based on your results in part two, state two geometric properties relating Ln to AB. Ln to AB. So Ln, first things first. Ln is equal to 2x minus 4y. Right? And A to B, A to B is equal to 2/3 2x minus 4y. Are y'all seeing anything there in common? Like, let me know. Let me know.
The 2x minus
2x
4y.
minus 4y.
So what I could do, right? I could say that AB is actually what? 2/3 of what?
2/3 of ln's.
Exactly. And if I could show that they are scalar multiples of each other, I could say that they are collinear, number one. Right? So I could say they are collinear. And I could say number two, that AB is 2/3 the line, 2/3 size of a line. I don't know if you guys understand this.
Yes, I get it.
Yes, sir.
Okay, weird. Is it 11:41? I think we have time for two more questions. Pick January 2024. See what's cooking there.
Yes, sir.
Well, we cover the whole of vectors. Great. I want to get a question that involves. Well, this vector question looking easy. Well, let me not like say easy and it might be a little hard. You see, right? But it's looking simple. Who want to do this question, man? Do I have any takers?
I want to try to.
All right. All right. Yeah, no problem here, right? So get the question I read from me.
In the diagram below, O is the origin, OE is equal to 2EF, and M is the midpoint of EG. OG is equal to C, and OF is equal to D.
Here one, right? Okay, first thing we should do is we should probably put on the information there. OG is what?
C,
And I got put arrow too, right? So O to G is C. Yeah?
yeah,
And O to F, which is this entire thing, is
is D.
right, is D. Awesome. And they are telling us that O to E is 2EF. So O to E, and we see that it's 2 of EF? Because this is 1 EF, right?
Yeah,
Take 2 EFs.
yeah, I can see that.
Right, would. And they say M is the midpoint of EG. Would. It doesn't look like the midpoint, but
I can see it, so I can see it.
yeah, so see more in the center over here. All right. So F to G now. How would I go from F to G?
Um, F to E, so
Right? F to E.
then E to M,
Yeah, I wouldn't recommend that. I wouldn't recommend that. Let me explain why. Do I know what E to M is?
No, sir.
Do I know what M to G is?
Um, no,
Nah,
sir.
nah. See, I have to work in terms of vectors that you know. So how could I go from F to G? So you said this route, but that route illegal. Go take that route. Is there any other route?
Okay. Okay. F to E.
Nah, nah.
F
Yeah,
F, F to O, sir.
right.
How the route illegal?
Oh, because we don't know what this is, and we don't know what this is, right? F to O plus,
O to G.
right. What is F to O?
Um, D, sir. Well,
Okay,
negative D, negative D.
negative D, right? Because O to F was positive D. So that will be negative D.
Plus C.
And I should probably write that as C minus D, right?
Yeah.
Right. So Olia, like, can we see that vectors is not really like a math heavy topic? It's not like trigonometry or like whatever. It's just like quote unquote common sense. Quote
Yes, sir.
Yeah, sir.
saying like lightly, right? It's directions. It's like how you gonna go from one point to the other point. Then E to G. Right. So Salmon Aaron, E to G now. So I want to go from E to G. Let me just get a picture of this.
Um, E to G, you'd have to go from E to O. And then O to G, sir.
Right. Now let me explain something. Um, so in the question, they said that O to E was two EFs, yeah?
Yeah,
And we know that O to F, the entire thing is D, right?
yeah,
All right. So in other words, I can split this thing up into three fractions, three portions, right?
yeah.
Out of the three portions, how much is EF?
One,
One third. And E to O, O to E would be what?
two.
Two. So two out of the three, right?
Yeah.
So we know that OF is what again?
OF is,
OF was what? OF was D, right?
yeah,
Right. So O to F is D, right? So as such, O to E would be what? What fraction of that?
2/3.
Exactly. So that'll be two thirds D. And E to F would be what?
1/3 D.
Right, one third D. But I have a question. If you want to go from E to G, right?
Mm-hmm.
Actually, never mind. Would that be legal? Yeah, it would be legal. If you wanted, we could go from E to F and then F to G because we
Oh,
to G.
oh.
Or we could go from, you know, E to O, which would be two thirds, which would be minus two thirds D, right?
Mm-hmm.
Plus C, because this is C. Was it? Yeah.
Yeah.
So what route do you want to take? Someone.
Well, I'll do E to F and F to G, so
Because in that way you wouldn't have to make this negative.
yeah.
But it's a possible solution, right? And it would work out. So E to G. So that's the case. You're gonna erase this. Cool. So e to g would just be e to f, right?
Plus f to g.
Right. E to f, we just said that was our theta d, right?
Mm-hmm.
Right? And f to g, what was fg?
C minus d.
So you're not seeing it, right? But this means a minus one. What is that?
Yeah, so it'll be a third minus 1.
That should be minus 2 thirds d. Just verify that.
Yeah.
Yeah? Or no?
Yes, it is minus 2 thirds d.
Okay, good. So my answer is C minus 2 thirds D. That's after that. Easy?
Yeah.
C minus 2 thirds D. All right. Over to M now. So I want to go from O to M. So I'm going to connect O to M. So we're going to go from O to M here. So what are the routes I could take, Aaron?
O to G and then G to M.
Yeah. And I could also go from O to E, E to M. Yeah.
Yeah. Yeah.
Right. Well, O to G is C, and MG will be what fraction of, later. Let's check something out real quick. So we found E to G, right? Found E to G.
Yeah.
So we know that E to G is,
E to G is C minus 2 thirds d.
and we want to go from G to M, right? First,
Yeah.
that would be what fraction from G to E?
I think a third.
Nah, remember it was the midpoint.
Or a half.
It was a poorly drawn midpoint. So this would just be a half of GE. I'm gonna that confuse you.
No, so I get it.
So that would be O to G. Now we know that O to G, right? O to G is C.
Yeah.
Now G to M would be a half G to E. But we need to understand that G to E is in the opposite direction of E to G. So that would be a half of, so let me just write it over here, right? So G to E
Mm-hmm.
would just be negative EG.
Yeah.
We found EG to be C minus 2 thirds D. So this will work out to be 2 thirds D minus C. Yeah or no?
Yeah.
So I'm going to put 2 thirds D here minus C. So that's going to work out to be C plus a half by 2 thirds is 1 by 2 is 2, 2 by 3 is 6, minus a half C, right? So 1C minus a half C is just a half C, right? Plus 2 over 6 is a third D. Just verify that.
Wait, so a half times 2 thirds is that 1 third?
Yeah, yeah.
Oh,
Because 1 by 2 is 2, 2 by 3 is 6, 2 over 6 is a third.
yeah. Okay, I get it now. Yeah, this is correct. So,
Right? Yeah. Yeah. So you feel like you're much better with vectors?
yeah, so
Okay, I want to do one more question on vectors, but not these kind of questions, questions with the column vector and whatnot. I noticed that they don't bring questions like that in the newer years. They rarely ever bring questions like asking you to find the magnitude, the column vector. They quicker asking you to find these kind of questions, right? So let me just run through back O to M, right? If you wanted to go from O to M, you had to go from O to G and then G to M. Now, this one's simple. It's just C. Now, in the prior question, we found what E to G was, right? So E.
Yeah.
Now, if we want to go from G to M, we'd have been going in the direction G to E. Now, it's important to realize that G to E is just negative EG.
Mm-hmm.
This negative 2/3 returns to plus 2/3, and this positive C returns to negative C.
Yeah.
So, and the next thing, right? G to M, this is the midpoint, right? So that would just be a half of GE, right? So this is G to E, and this would just be a half of that. So we found GE to be 2/3 D minus C, so a half of that is just 2/6D minus a half C. 1C minus a half is a half C plus a 30. So
Yeah.
Ira, sure you understand this, right?
Yeah. Understand.
Okay, good. Then now on the rest of you guys, Adika, did I like real confused? Like, I know it looking a little confusing, eh? It does, but like, let me know if you want to go over anything in particular.
No, sir, I think I understand. I just need some practice.
Okay,
Yes, sir.
when I do all the practice, make sure and send it to me, right? I'll correct it and we'll go from there. Let me
All
go back,
right, sir.
go back in the past. So like in my old year.
2018, January 2018.
Okay. So determine the vector O to Q, right? All right. Good. So guys, a little tricky, right? But if you notice they're giving us O to P and they're giving us P to Q, right? Tell me, if I wanted to go from P to Q, I would first, and remember, I told you guys that in these types of questions, you're using the origin as the middleman. So you'll have to go from P to where?
P to Q?
Nah, you don't just go from P to Q. Like if I end P to O,
Oh, P to O and O to Q.
right? And we don't know what O to Q is. So we have to make that the subject of the formula. So P to Q is what here?
It
3
is
over
1 over
4.
2.
Right? Now P to O. So guys, we have O to P, right? But do we understand that P to O will be in the opposite direction? Yeah or no?
Yeah, so
So if O to P is 3, 4, what do you think P to O would be?
negative 3 over negative 4.
Guys, do you understand that? Danelle, Adika,
Yeah,
guys.
so
Yes, sir.
So guys, again, if I'm going from O to P, and that's 3, 4, the opposite direction would have a different sign. So minus 3, minus 4. And of course, I'm finding for O to Q. So if I'm finding for O to Q, take this, I'm going to move it across. So that's going to turn to minus 1, 2, minus open bracket, minus 3, minus 4. And that will be equal to the OQ. So look at how I'm going to do this, right? I have minus 1 here, minus 3. Over here, I have 2 minus 4. And that should be equal to O to Q. So guys, somebody work that out for me and tell me what O to Q is. Guys, what is minus 1 minus minus 3?
Two, sir, two.
Right? And if you're wondering why, minus by minus is a plus. So this goes into plus 3. And minus 1 plus 3 is just 2. Right, next
Two
one.
over six, sir, 2/6.
Minus 1 minus 4 is 4. 2 plus 4 is 6. How many of you guys go with this?
Yeah, sir.
Yes, sir.
Again, guys, in vectors, we typically use the origin as the anchor point or the middle band. Right? So if they ask us for O to Q and you see P to Q, just know to go from P to Q, you'd have had to go from P to O and O to Q. And an example of this would have been when we was doing the drawings over here. Look at this, guys. For me to go from Q to P, how did I move? Somebody tell me. To know. How did I move to go from Q to P?
You gotta go to Q to O, then O to P.
Right? That's it. Awesome. Right. Show that O to Q is parallel to R to S. Now, if two vectors are parallel, then I could write them as scalar multiples of each other, right? So O to Q is 2, 6, and R to S is a third. I think everybody's seen what they have to do. Let me just go to the question and you'll see it clear as day. So yeah, guys. Let's see a relationship between RS and Q.
Yes, sir.
Come on.
So it's like twice the amount.
Right. So OQ is actually how much OR, how much RS is.
2.
Yeah. Once you can show that vectors are scalar multiples of each other, they are parallel. That's it. Right? Therefore, OQ, RS, parallel. Additionally, OQ is 2 times the size of RS. Right? But guys, really, like truly speaking, is all they had to put. OQ is equal to 2RS, right? This is a geometric interpretation, which is like another mark. But it's just a 1 mark question, so this is fine. Right. Who knows more this question? Guys, do I have any volunteers? Aaron, you there? This is the last question for the night, eh?
Yeah, sir, I hear.
All right, so Aaron, first things first, I should probably draw a triangle, right? Because they say,
Yeah.
why is he that triangle? I don't even know what it's looking like. So I can say this is X, I can say this is Y, and I can say that is Z. I confuse you?
No, sir.
And I say M is the midpoint of XZ. So if this is XZ, the midpoint could probably be somewhere over here. Yeah.
Yeah.
And they say X to Y as well,
X to Y is A, and
right?
Y to Z is B.
Right. That kind of look like X to Z. See now?
Yeah.
Wow, wow, look what they're asking me, X to Z. Wow, right? Who that thought? So,
It'll be x to y plus y to z.
well, yeah, X to Y plus Y to Z. And that'll be equal to,
A plus b.
that was cake. M to Y now. And this is M, right?
Yeah,
So if I want to go from M to Y, that would be,
it'll be m to x, which is half xc, and then x to y.
right? So M to X is just a half. So you just found X to Z, right? We just found X to Z.
Oh,
Gotta be careful, right? Be
yeah.
careful because because X to Z, right? X to Z, truly speaking, is in this direction. And X to Z was just A plus B.
So it'll be half a plus b.
Not so fast. If you're going from M to X, right? That'll be going in the opposite direction.
Oh, right.
So that would actually be half of Z to X. You
Which will
understand?
be a minus b, sir.
Yeah. So that'll be a half of minus A minus B. You understand why I said that?
Yeah,
Because again, A plus B here. So this could be minus A minus B and half of that. Right? Plus XY, X to Y is A. So you're gonna end up with minus a half A, minus a half B, minus a half A, minus a half B, plus A. So you're not seeing it, but that's 1A, right? So
yeah, I seem to like terms.
that's gonna be a half A minus a half B. Was that the only way you can answer the question?
No, sir.
Yeah, that was another way. What was the other way?
M to z, and then z to y.
That'll be easier or harder?
I I mean I found both ways kind of easy, sir.
That's true, but like I feel like students would like mess up with this part. Because like even you saw A plus B, where that'll be minus A minus B.
Okay, I can see that would catch them.
For sure. So this is more safer solution. So you want to go from M to Y. So wait. Yeah, M to Y. So why did I put a down arrow here? Who knows? M to Y, right?
Mm-hmm.
Yeah. That would just be M to Z, right? And Z to Y. Now M to Z is in the same direction as what?
As x to z, sir.
And X to Z was?
A plus b,
So this would just be a half
a
B,
plus b
and this would just be minus B.
minus b.
Yeah, so that would look a little easier. A bit easier. But truly, if you know your stuff, that wouldn't get you in trouble. Like the first method wouldn't get you in trouble, right? M to Z plus Z to Y
I
to Z would be a half A plus B right? Plus, I just put minus b, right? So you're gonna end up with a half a,
Plus a half b minus b.
and they're gonna end up with
A half a plus a half b.
minus a half,
Oh,
because minus one,
yeah.
half minus one is minus a half. Yeah,
Mm-hmm. That's the same thing as the first solution.
exact same thing. So yeah, how you feeling about, like, you feeling good, right?
Yeah,
Ready to mash up that exam.
yeah.
I was still not satisfied. Like, I remember there being different types of like questions. They're like real dig into the past. No, this is not the type I want. Like, I mean, maybe the ones I'm talking about are the same June. Let me check like June, yeah, June 2019. That 2017? I see that thing. I don't see any types of questions I'm looking for, which means that they're kind of rare. So it's like an off chance it'll come this year. But still, they should know how to do it. Okay, here's the questions I'm talking about. Right. So Aaron, let me handle this question fast. So they give us a diagram, right? They want me to write OR as a column vector. So how would I go from O to R? Tell me the horizontal first and the vertical.
Um, O2 was, I can't see the other letters.
Dan, you're overthinking it. So look at the diagram, right? How could you go from O to R? Tell me, this is a column vector.
Oh, you go one space to the left, and then four spaces up.
Yep. So what would that be as a column vector?
Um, -1/4.
Right, negative one, 4. Right. And how would I determine the magnitude of Q to R? Well, to do that, I would first need to find what Q to R isn't.
Yeah.
And they said, okay, they never said use any graph, but I'll show you something really cool. If you use the graph, you could figure out what Q to R is, right?
Mm-hmm.
John, Q to R is just how you would go from Q to R, right? How
Yeah.
from Q to R. So if I wanted to go from Q to R, I would move these amount of spaces to the left and then this amount of spaces up. So that would be from 5 to -1. So that's 6 spaces. And then 2 to 4, that's 2 spaces. So that would be 6, 2. -6, 2.
Okay, so
That's how you could directly read it from the graph, yeah?
yeah.
If you want to do the calculation, you would need to know what Q to O is and what Q to O plus.
Um, O to R. So,
Right. So Q to O would just be negative OQ. So OQ, what is O to Q?
uh, 5, 2.
So I'll say now my answer is -62. Let me see if we get that using the long method. So I'll be 5, 2. So 5, 2. That's 5, 2. Right? And as OQ, so minus OQ, that'll just be -5 -2. Right? Plus O to R, and we know O to R is -1/4. Well, like, will we get the answer that we got when we looked at the graph. Did we get the same answer, Aaron? Minus x2?
Yeah, sir.
Yeah. So now that we have QR, how do I find the magnitude of QR?
X is the square root of x squared plus y squared.
So what is x here?
6, negative 6.
Right, so that'll be negative 6 squared plus,
2 squared,
so negative 6 is 36.
36.
So that'll be 40 inside here. So that'll be the two decimal places, that'll be what?
Um, 6.32.
Right, and if I ask you to find the direction of the vector, how would you do that? Do you remember?
It'll be 6 over 2, sir.
Tan inverse.
Sorry, tan inverse 6 over 2.
Right? Let me know when you get.
I got 71.57.
And if you have trust issues, watch this, right? So that is, we just don't find the direction of QR. Watch this. Okay, now we can all source. 6, 2. Okay, now we can all wait. Let's scratch this question off because again, we use that for direction vector. I mean position vectors, and QR is not a position vector. So that could breed trouble, right? We will only find the direction of a position vector. Can we both see that QR is actually a displacement vector because it doesn't start from the origin?
Yeah.
Yeah, so that's gonna be trouble. So yeah, that's it for vectors, guys. We covered every single thing. You guys okay with vectors now?
Yeah, sir.
Okay, nice. So tomorrow, there's so much work we can do. See you all at 12 o'clock, right? We do 10 hours on maths today, give or take, because 12. I don't know.
Yeah, we started at 12, so we finish at 12.
Yeah, right. So guys, have a blessed night. See you later
Same
tomorrow.
to you, sir.
You too, so good night.
Good night.